Hello everyone. Are we live? It's at the right time. I didn't brush my hair. I hope this microphone is okay here. Hello, Mr. Johnny, and hello, Lars, and Jordi, and Embedded Hobbyist. Hey Ben, Lewis is also here. Matthias, hello. Oh, look at my wall. Something's wrong there. Uh-oh. What happened there? Uh-oh. Fail.
Wall failed.
Yeah. Oh, hello Peter, M40K, MAKK. There's something. It looks like.
Looney today, the 16th of December, Victory Day of Bangladesh. Smile.
Oh, congratulations.
Turning it off and
Or
turning it back on again.
I don't mind. It's okay. I have strange pants on today, so it's very like skinny.
Bit have an idea. Let's make a 3D RGB hologram fan.
Oh,
Yeah, right.
okay. Yeah, let's collect the ideas as always. Today is one day challenge week. Let's hope for a project that's doable within 6 hours or something. I really don't want to work all night, but let's check out. Okay, so we have a suggestion for let me share the screen. Should I make it the hair louder? I will turn the knob louder here. Here. The knob should be louder now.
Fondue shop is open again.
Yeah, fondue is open, but it's non-alcoholic version of the fondue. And I don't have schnapps to put in there. Let me turn the camera a little bit so the wall is more centered like that. Oh, that annoys me, this bug there. It looks like one of the LED before it starts like bugging out, one of the LED is like failing. I don't know, maybe turning it off and on again.
Just threw some wine or beer in it.
Oh, wine! Wine is a good option. I didn't think of that. Some white wine. I should have some white wine, maybe some Riesling or. But let's do the other stuff first. Okay. Yeah, I'm sorry that I forgot to, or I had a mishap setting up the stream. The title was wrong and the time as well. Hey Aaron. Vivek is also here. Vivek, did you take your name from the game Morrowind? Schnaps or Kirsch?
So bitluni was just being
Saltima.
loony.
Yeah, Saltima, I don't have neither schnapps or I just have like plum schnapps, and that's not, I don't like that in my fondue. So random hacks assault. Oh, Fruchtzwerg is, I miss a few people. And Little Fish hello as well. So Victory Day. Okay, Photo Max is here. Oh wow, we have a full chat room today. Okay, people. Oh, that's not the right desktop. I wanted to. No, that's not the right desktop. Oy. Let me change that. Why this? Somehow. I want no. Huh? Yeah, here we go. This is what I wanted to share. Okay. Let's add to the list. There was a suggestion, like what was it? LED fan, POV LED fan. Oops. Here we go. Oh yeah, make a new IP address detector with printer output. Yeah, we had that. Where's it? This is the IP sniffer printer. What's wrong with vodka? I don't know. Okay. Oh, that you mean like detector, like detecting if there is an IP address, or? Yeah, we can figure that out with this IP stuff printer, IP sniffer printer, yeah. OCD.
3D printer camera.
3D printer cam. Louis, shouldn't you be like suggesting another project? What did we want to do yesterday? There was like, oh yeah, MIDI automaton. What's with that? Don't we want to try also MIDI automaton?
I vote for Lewis, his idea.
Okay. Louis, okay, 3D printer camera. What? 3D printer camera. But I don't have. Oh yeah, 3D print. Wait, we have. We have. Do we have a 3D printer camera somewhere here? Wireless 3D printer cam for OBS. Okay, let's. Option 22. Peter. Yeah, printer camera with ESP cam. Okay, let me set up the vote. And today's project will be one of the following here. And we get 3D printer, OBS, cam, source, whatever. Okay. Just Pi 0. Okay, 3D printer. I have a Pi 0 here.
It's possible to use the 32 Spanish pesetas cam with RTSP for video streaming to then OBS or even VLC media player for testing 8_.
Okay, we have a plenty of options here. I even have a Raspberry Pi 0, but I don't have a camera that you could connect to that. I don't have a Pi cam. What kind of camera can you connect there? What type of connector is that?
Wireless powered LED baubles. We need Christian's theme.
Wireless powered LED baubles? What are baubles? Is this some kind of British term? Bauble.
Every USB wecam.
Oh, USB.
It's a CSI camera connector, but you can also use a USB camera on the Pi Zero.
Oh, USB camera. Okay, yeah, we can do that. I have plenty of spare cameras. I have the old Logitech.
Baubles is a Christmas decoration.
Oh, yeah, yeah, the glass ones. Okay. Xmas decoration. Okay.
Christmas tree baubles.
Okay, okay. Okay. So, laser oscilloscope. Oh, that's something for another day. We can do that, a laser oscilloscope. But not today. I don't have a Galvo. We need to build a Galvo first. Booby. Like music to G code. Okay, so but I think Peter, I think there is like something like that already. Music to G code.
POV LED fan. 3D RGB hologram fan.
3D RGB hologram. Okay, yeah, let's do the POV fan.
A cannon that has all the tree decorations in it and fires at an undecorated tree and decorates it instantly too.
Okay, that's a stretch goal. Like, okay, we have one option left for the vote, for the first vote. So we have the camera, Xmas decoration, POV fan. Then do we do like this sniffer or the MIDI automaton?
The POV LED fan.
Yeah, it's not like that, Hannes. It needs to be voted. So
Laser video projector.
and the fusion reactor.
IP sniffer.
IP sniffer. Okay. Oh man, the automaton would be a really cool project, but we can do this another time. Okay, sniffer. So you people want
Option 22.
option 20.
Amplification by stimulated emission of radiation.
Yeah. And what's scuba again? Okay.
VGA oscilloscope.
Ah, it's too late. We have 4 options now, and I will start the. How do I start it? Okay, here you go. I will grab some wine if I can find some.
MIDI.
Ah,
Self-contained breathing apparatus.
yeah. And I will restart the wall. I need to power it off.
Self-contained underwater breathing apparatus.
Wine. Oh, hier ist noch Müller-Thurgau. Ja, ich glaube, ich brauche hier einen Kopf. Wir haben 15 Korkenzieher da drin. Oh Gott, kriege ich ein Weinglas hier raus? Okay. Ich brauche ein Weißweinglas. Okay. Bis gleich. Später. Okay, people, what did you vote?
WIR haben 15 Korkenzie her da drin. Ich brauch ein Weißweinglas bis gleich Spatter.
Yeah. As soon as I...
This should make a miniature hyperloop PVC piping a puller vacuum.
Yeah, but we don't have PVC pipes here. Okay, I restarted the wall and I hope the LEDs will work again. We have this nice Müller-Thurgau Aldi selection from 2018. It's the El Cheapo. Oh.
Go with a real schnaz.
Schnapps.
Even bitluni sounds angry when he speaks German.
Angry German. Okay, so what's going on with the vote?
That's what we are going to say when we are living in futuristic houses and stuff.
Okay. Wall doesn't boot up. It's somehow always struggling to boot up the first time.
I would like to Wi-Fi GPIB interface to read test equipment over Wi-Fi.
Okay. So let's test again. Yeah. Wall. Oh no, the LED is broken.
Worth more than its content. Do we still have warranty on the LED wall plus J3P?
Wait.
His wife is getting crazy with all our messages to bitluni.
No, she doesn't hear that. We are like, oh wait. Fondue cam. I have to reactivate this for this view. Nope.
Repair the wall.
No, we need to that's tedious. I don't even know. I might have replacement LEDs, but this is natural white, so the one LED that I would replace would be off. Okay, let's put on.
Ha.
That's not the one. It's not her. Her. Okay.
Poor. Pole balancing robot.
Okay.
Poor.
Her. Looney Gate. Okay.
Foul.
Okay, I quit the first one. Oh no! What's the result? The result is, oh, POV fan and IP sniffer. Okay, Xmas decoration is gone. We have to do a vote with 3.
All bets are cool.
Okay, final vote. Final vote to copy. Okay, and
We are just going to watch bitluni pour all of the wine into the fondue.
yeah, a bottle of wine. POV fan. And since they are equal, POV fan and IP sniffer, here is the vote.
Voting much shorter so people don't have time to switch accounts.
Yeah, it is shorter already. It's 1920, and we are in the second round already. Now let me taste the good old Müller-Thurgau. It's not even cold.
Data?
It's like 20 degree.
Extend chat TTS capability to allow command to accept the language or accent on the fly.
Another time. I will make. Okay, so I will pitch you this idea now. If you didn't like catch that when I was talking about the TTS earlier, in another stream, I want the system here to assign a language to a person randomly, so everyone would talk with with a specific language, so we can distinguish the people. And I think maybe on top we could like set a comment like language or something, so everyone could set their own language TTS, and the system here would just like store it and use the proper TTS for that. It shouldn't be that hard, but the first thing, we need to rebuild the TTS to maybe...
Beckon cheaters loony gate.
What? Cheaters? What I'm... Oh. Someone's cheating? Oh no, we still don't have 50%. Ah! Okay, IP sniffer is out. We need... What? What's happening here? Okay.
Ha, tied again.
No. I closed the vote. Okay, IP sniffer is out. Now, let's do a last vote. I call this vote final vote to copy
Option 22-1.
for sure now. Okay, we have two options here, and I know you guys will try to get an like 50-50 vote, but not possible. There are always trolls that will prevent that. Okay, POV fan and 3D printer cam. 3D printer cam. Okay, let's start the last vote. Fail option 22. Option 22 should be a meme. You need to remember option 22.
What is POV fan?
Oh, it's basically the same what my lightsaber, POV lightsaber does. So it's basically, I can show that. Can I show it? Oh wait, here. Okay, here. Wait a second. Okay. It will
Merry Christmas, everyone.
it will do the same, but like with a constant rotation. So it's too bright in here. I can even, I think I can switch. Oh no. Oh, it crashed? No. I think you could select like even the image here. Oh wait, let me just try again. Okay, so this is, but I mean this lightsaber. Sorry.
So cool.
Yeah, it's one of the coolest projects, and it's even not on my channel. It's on Electromaker's channel. Okay, 3D printer cam seems to be dominating here. I will end the vote now. Looney Gate, option 22. Okay, and we didn't even need half an hour.
Is it a Force FX lightsaber?
Sorry, what?
Wow, I want a lightsaber.
Yeah, build one. It's not that hard. I think.
cheese.
Cheese. Okay, so Raspberry Pi Zero here. We got it. And now we need an interface.
We need to start a fund to allow bitluni to buy some proper trousers and shoes.
Did you see my shoes? It's at least comfy. Okay, I got a Pi Zero here. We just need to...
Don't need a Pi Zero, just use an ESP32 cam. Amazing shoes. My opinion of you has changed.
What? Okay, okay. The ESP32 cam. Let me think about it. We can use either the cam. So we got it here. We got it here with camera installed, or we use an USB cam and can.
Do you use Octoprint?
No, I don't use Octoprint. So maybe we should try Octoprint with that.
I have an ESP cam.
But the problem with the Pi Zero is that we only have like 2 micro USB ports, and one of those is power. So we have 1 micro USB port. Use ESP32 cam OTA. Can we?
Is that 02W?
No, I think it's the first one. Yeah, it's 1.1. It still has HDMI.
I can't do anything with a doggo sat on my lap.
Thanks for sharing this information with us. Okay, I will try to the fondue for now. It's still a little bit
Is it a
gooey.
0W?
Yes. No, wait, it is. It says Pi 0W version 1.1. It's never used. I have like ages here. 2017.
You need a USB OTG hub powered adapter.
OTG powered adapter. I have no clue what you mean with that. Oh.
Just point your camera to the 3D printer and be done with it. It is already hooked up to OBS.
Oh, this alcohol-free fondue is terrible. It tastes like some cheap ass burger cheese or something. Schablettenkäse in German.
Ha 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 ha. Just use URP2040 etherboard.
What? Everything needs booze, yeah. I need to like
3D printed fondue.
3D printed fondue. Oh, where are we? Okay, let me change the title.
Use URPOE board.
Oh yeah, I could use that. But we don't have a camera interface there.
Just flavored plastic.
Yeah. Okay, so 3D.
Those cheap adapters with USB Type A, Ethernet and USB micro. If it's powered, can also power the Pi.
Oh yeah, okay. I have somewhere here. I have like a hub, USB hub. I have plenty. Oh yeah, that one here. That has some power stuff. But how do I connect that? How do I connect that? I had an adapter from micro USB to normal USB. Oh yes, the best that
Okay, just use an ESP cam.
the best spent money. Okay, but we can't run.
Anchor induction powered hot ice cube to keep coffee hot.
These are the best spent 30 cents on AliExpress. This is something you can, I will show it here. You can basically plug that in and get a micro USB. So we can use that for this one here. I need still the USB cable here, that one. Okay, so I would rather use.
I have 2 of TT Hose OTG adapters in my wallet.
Okay, look at that.
Those adapters are the worst thing to buy. I brought several and they keep hiding.
Yeah, I just by coincidence I just found one. Okay, here, and I even should have a power supply for that, so we can check if we can power this. It's huge. I should have a small hub here somewhere. Here. But I'm not sure if that one is still working though. Looks a little bit broken. That one is with mini USB. So we don't need this huge chunk here. That would be enough. So the reason why I rather would use a Raspberry Pi is because Octoprint would be quite nice to record some time lapses during the printing for the videos. So let me set this up. I will grab the power supply for that. I think I saw one here. Oh no, what is that? Chaos. Pure chaos here. Okay, here's the... This should be the power supply. Okay, we got one. Now we need... Yeah, I'm coming back, coming back. Okay. Okay. So,
How well does Octoprint run on a first generation Pi 0W?
I have no idea. This is the first time I would set this up. No, wait. I think I might have tried Octoprint like ages ago. Ages. I barely remember.
What project did win?
The title should be updated. It's... Okay. It's a 3D printer camera, and we are setting up a janky. This is a powered hub with...
This is a 0W and not a regular 0, right?
Yeah, it's a 0W. Oh, this is very fluid.
You need to add a stir command so we can stir it for you.
The stirrer is in the list. Nobody voted today.
What could be special?
What could...
Would fail a fail if it failed to fail?
I don't know what's... It's not special today. It's like a very boring... It's a very boring project, I would say. Okay, we found a webcam here. And now we need to... Yeah, maybe we can do other stuff at the end. So...
Boring but very useful.
Yeah, you people want always to see what I'm printing over there.
I can't type.
Okay, let me plug that in, that contraption here, this Raspberry Pi contraption, and see if it's even boot. How much power does this deliver? 2 amps? This puny power supply delivers 2 amps? I don't believe that. Okay, let's see.
I voted for watching paint dry.
Yeah, option 22. Here we go.
Bitluni is making a bomb for sure. We only have 12 hours to go.
12 hours? I think I don't need that power supply. We can remove the power supply from the equation here. I will basically use a short USB cable for power here. Okay, I will change that contraption here. I don't like that. We don't need that hub in between. We have 2 ports.
I plugged a Pi into a 6-port hub, so it was both powered by the hub and used the hub to give it extra ports.
Oh wait, if we want to use Octoprint, we need the extra port for okay, so I will leave it. But I don't know if it boots up or anything. It doesn't show anything. Okay, the camera goes in there. Okay, the port, the hub seems to be powered, but I don't know if the power is going to the Raspberry Pi. So how do we find out?
Power the Pi from the hub too.
Yeah, but how? I don't know if it's directly connected or not. if there is a diode or anything. Oh shoot. It's like fluid. I need to cook it. Now it's too much wine in this. But it's a...
You will need a micro USB cable from the hub to the Pi's power in.
Oh!
The USB hub shouldn't backfeed power to the host.
Okay.
Just add more cheese.
Okay, if this is crazy.
Such thing as too much wine.
Okay, so this contraption here, we have a power supply that's powering this small hub. Then we have connected the Raspberry Pi power connector to the to this hub, and we have also the hub connected to the, like in both directions. Okay, I need an SD card now. Stir. Oh yeah. It needs to cook a little bit.
I like red wine on my chips.
Really?
Bitluni made a USB Pi necklace, job done.
Okay. No, it's not that easy. It's not that easy. Okay, that's too hot. Oh, I think this SD card is broken. The SD card that I'm trying. Okay, I still have a 32 gigabyte SD card. Okay, let me check that. Is there an image somewhere with?
MS Paint drawing of the wiring diagram, please.
Okay, we will do that.
I have a ton of dead micro SD cards.
Yeah, this one is dead. I will put it upside down in my holder here. No, holder won't take it upside down. Okay. Okay, the fondue is a fail today.
We need to build a 3D printer that prints molten fondue cheese onto bread. Looney is trying to add some pressure to the project by pretending a bad memory card drawing an NFT.
Okay, I can prove it to you. Let me prove it to you. Here, I will open that. I will insert the card. Okay, we need some dramatic music for that, for inserting the card. Where is the dramatic music? Do I have dramatic music here? This is not a dramatic music.
Disk mgmt.msc that will show the card might not be formatted. Card C. Is this challenge just a basic 3D printer owner administration task?
Okay, so this card, no, it doesn't recognize it at all. I can't even format it. I think I had problems with that one before. Okay, let's try that one here. Okay, that one works.
Run disk mgmt.msc. Keep it going, it has a Charlie Chaplin type vibe to the video stream.
Okay, okay. Okay, let's try the other one again.
Don't listen to the suckers and get a proper card.
Okay, I will try. Oh, come on. Okay. It's loading.
We need Yakety sax. Benny Hill theme.
It's still loading.
Bitluni card reader deactivated in BIOS lol.
No.
Bitluni.
What happened?
An SD card to work 2021 colorize.
What? Okay, you know what? That's yeah, it's hot. It's even hot, so that card is broken. When I pull it out, it works again. So that wouldn't work.
Stream dixing Looney's computer, it seems.
Yeah, we doxing my computer. Okay, so let me check what's on that card. Novatech.
Thermal runaway SD card.
Oh shoot, what's that? I need to secure the data first. I have no clue what this is. Okay.
I've had my fair share of them. Bitluni Productions brings you some random non-German guy trying to get an SD card working. Today's challenge, find an SD card.
Today's challenge fun. Oh wait, I need to update the list. Acoustic levitation was fun. Okay.
Is it okay if an ESP32 gets warm when it has nothing connected to its pins?
Yeah, it's okay. That's the typical state of an ESP32. Especially if you're using Wi-Fi.
Is this a 16 terabyte card? Lunaland pics.
No, it's only 16 gigabytes, but it's full. I think I used it in my phone before.
What's in there? Today's challenge has been made even harder by wearing female trousers and shoes at. Make it play a sound when the printer is done.
Okay, yeah.
Why is everyone writing fail in front of their messages?
Because that's read out loud, and otherwise I might miss the message. It's a fail notifier, but everyone uses it to communicate basically at this point.
We want Looney in high heels. Looney, I'm your printer. Come and get your stuff.
Okay. We can connect this to the wall or whatever. So we can make it really IoT, the Octoprint. I don't know what's possible in Octoprint.
Make TTS available per super chat only. I am taking 25% for this idea.
Okay.
High heels Bitluni. I can make that a thing proceeds to open GIMP. I definitely don't want to see Bitluni in high heels.
make Octoprint IoT. Then what else do we do there? We want to notify on wall or whatever.
Pink high heels H backquote L.
Notify over TTS. Okay, that's cool. That's maybe the challenge for today. And okay, what kind of bonus do we have?
Bitluni,
No bonus
turn
yet.
out the camera and stand in the middle of the room for a second.
No.
Convert your SMS smoke detector into a 3D printer done notifier.
That sounds like the invention of Homer Simpson. I don't know how it's in English, but it's all good like detector. It always gives out this high tone. Oh, thanks Peter for the donation. It gives out this shrilling tone whenever everything is all right. I need to get a proper fondue. Man, this is terrible.
I am not paying extra for this boring live stream.
Watching my SD card downloading.
TTS does not read super chats. That is a shame.
Oh no! Oh Peter! Sondereinsatzkommando. I will do it. I will do it for you. You get a service.
EUR rules, no Sondereinsatzkommando.
Okay. That needs to be fixed. Yeah. Super Chats. Unbekannter Fehler aufgrund. There is another. Okay, I need dramatic music. Let me pick some dramatic music. This is not the. Let me check.
Sex.
Where is my Where's music? Music.
This challenge just got serious now.
Yeah. Where's the dramatic? Yeah, it's underwhelming how long it takes me to find some music.
Where is my Roflaro FL Roflaro FL Roflaro FLRO FL
What?
Talk plus panic. Music from the day the earth stood still.
No, but something. Action.
Back to the future theme. Back 5% H backward L.
It's stalled. Okay. Yeah, it's done.
Don't copy the floppy SD. Yeah, Herman Kenny copy first with an FY.
Oops. Okay, now everything is gone. Everything that didn't want to be copied was erased. No, I can't use any themes because I would get like demonetized, whatever. Whatever happens then. Terrible things happen if I don't if I don't use proper. Maybe this is not even, maybe this is some kind of vegan cheese.
We'll monetize this stream for ya.
Oh, thanks, Aaron. Okay.
Cheese fail?
Oh no. Yeah, it might be some kind of...
Cheese is always vegan.
No, it's not. It's vegetarian, but not vegan. I need to check that. If this is some kind of vegan cheese. Nothing against vegans, but my cheese, I like my cheese milky. Dairy. Oh! Hot. Accident counter reset.
Oh, you're right. I was confused about those two. If you break copyright, they move a young influencer talking about makeup tips to Mars. So, what are you waiting for? Exclamation mark, exclamation mark, exclamation mark.
Okay.
Days since accident -0. Vegan cheese is not cheese. Rip loony. Since previous accident, 0 femtoseconds. Seconds since last accident, 5. Is vegan cheese human breast milk cheese? Vegan cheese is like cold margarine.
Raspberry Pi Imager. I think I might have Imager. Yeah, I got this app already. Yep.
Cheese from the boobies.
Stop. There is a newer version of, yeah, let's got it.
PFFFFRPI Imager. This message was made by New DD Gang.
I need to update it.
Cheese bought with sex.
Dudes, please. It's only 8 o'clock.
Sex like Swedish krona.
What? Oh yeah, SEK. Like, why does it take so long to download 18 megabytes? This doesn't taste like cheese at all. I need to check if I get some cheese up there. I need more cheese. Okay.
Warning, magic smoke detected.
Where?
Let's talk about sex, baby. Let's talk about you and me.
I got some Emmentaler.
Volume fail.
What? Volume fail? Oh wait, you need a second receiver, second transmitter close to the TTS, and I hope it's not too loud. So here you go. Now your TTS volume will be greater, better.
Cheese rescue.
Okay. Let's add some chunks of. This is the wrong.
Warning. You are down to your last 5 happy little accidents and walk away sort of unharmed for this year. Testing.
More cheese. More proper cheese here. Okay, we need still to download some kind of image. Okay, downloaded that.
Thanks for TTS Louder Maker. He's definitely harmed. He's wearing female trousers and shoes. Emmentaler into fondue. Boo.
Yeah, Peter, I'm sorry, but if there is no I checked the box again. If it's like some vegan or analog cheese, it says it's a Swiss cheese.
And yesterday he became a furry.
Oh yeah, yeah. That's my paws. My feet are paws. Her. Okay, finish. Imager should be updated now. Okay. Oh yeah, we have some.
Poor.
Other specific purpose 3D printer.
Analog
Octopi.
or digital cheese?
Yeah, digital cheese. Octopi. That's it. Stable. Let's use that. I hope that SD card. And right. Yep.
You look like that guy Fro. Dumb and Dumber in the ski outfit and fluffy boots in the Lamborghini. Home assistant.
Dumb and
Listen,
Dumber.
Looney, Peter, me, learned chef in my first life, and can tell you I am freaking out over the Emmentaler fondue.
Oh, really? So what kind of cheese would you do? Bergkäse? What kind of cheese would you put in a fondue? I have Frankendamer, but this is like Dutch cheese that doesn't belong in a fondue. So this is Emmentaler is something that is like coming from the Alps. So it's the least.
Press Ctrl Shift X in the menu of the imager. Digital cheese, is that when you haven't cleaned your hard disks in ages?
Control Shift
Fondue
and
cheese,
X.
of course.
Why?
Kangaroo cheese.
What does it do, M40K? Kangaroo cheese? What? Is there actual kangaroo cheese?
If you have Applewood smoked cheese, try it.
Smoked cheese? Dutch cheese?
Now I'm offended. Dutch cheese.
Why are you offended? I don't know. We can do it, but like originally fondue is a Swiss dish. So I would think that there is no like Dutch cheese. Even though I eat Dutch cheese, I love all the Dutch cheese types. But I thought
Control-Shift-X allows you to customize the image, like the host name, Wi-Fi credentials, lab, boobies, SSH enabling.
Oh,
Chocolate fondue for next stream with fruit. I'm Dutch upside down face. Hi NR. It's a shortcut to configure Wi-Fi.
Okay. What
You
is
know why it is
overscan?
called fondue cheese? Because they put this cheese into fondue #lifehack.
Octolocal. SSH. Okay, let's do it. Password for Pi.
Overscan is for displays. Overscan is for a screen.
Public key. No. Wi-Fi. Lab.
Password pink LED. Overscan is only affecting composite outer fake. Password long boobies. Nice password.
What is that? What is that? Wi-Fi land. Oh no, let's Zeitzone. Oops, Europe Berlin. Tastatur Layout DE. Tonsignal nach Beenden abspielen.
Ovariscorn is for having babies FN_RR CHGYP% L5R DAR.
Sorry, didn't listen. What? Overscan is for having.
Isn't that for Wi-Fi bands and strength regulations?
Oh, we can add some. We can. Oops, what is it?
Yup.
Can we set this to US? I want a really strong 1 watt Wi-Fi land. Oh, US. Yeah, let's do US here. Because otherwise we are limited to below 1 watt sending power. This is not legal. This is not legal advice. Okay, did it change now, or should we just restart the right process?
Type U on keyboard H_L.
What?
Don't do it, you will get swatted. Call the police. Bitluni is breaking the rules.
No, I'm only if it would penetrate the outer walls of the rooms here, but this is like steel concrete. The Wi-Fi signal doesn't leave the house.
I mean, we can swat bitluni anyway.
Thanks. Oh, this is.
You will have to reflash now, bitluni.
Okay. Let's reflush. Oh, I need to re-enter it. Okay, here we go. Oh, this is easier than I thought. It's better. We fixed that fondue a little bit. Peter still owes me the explanation what kind of cheese I should put there, except for Bergkäse, but I don't have Bergkäse here. Berg cheese. Oh!
Non-dramatic music needed.
Non-dramatic music. Okay, let's put on some non-dramatic music. Burned my tongue. Okay. Here you go. Oh shoot.
This sounds like phone hold music sorta. Looney's lab, hold on a sec. Thank you for calling bitluni support. Please hold while we connect you to Matthias.
Okay, you probably like this one more. No. You should if you're watching the main channel, you should know all these tracks. I have used them all in some kind of video already.
Still the imager? How often do I have to leave for a smoke? Hashtag most unhealthy stream. We need elevator music. I know them all. Tony Hawk's Reginald theme. How about music from Freelancer?
Tony Hawk's
You
Reginald
should
theme.
send all the music you use in a channel on Discord.
Wait.
At Sniff, it goes like this: if you know one, you know all.
Wait. You Tony Hawk
Please
Reginald
hold, he's
instead.
on Pornhub. Won't be a sec.
What? Okay. Okay. We are done with the SD card. It's red hot. Let's put it in the Octopi. Plug it back in. It blinks. Okay, it blinks.
We are done with the SD card. It can go in the bin. Elevator music, very uplifting.
Uplifting. Yeah, this is the one that you probably know the most. I really like to use that recently.
I had a typo. Tony Hawk's original theme.
Oh, really?
Bitluni. You have to press WEITER.
What do I do?
I can play this on guitar. I forget what it's called.
Really? You can play this. It's Orange Foot.
Is there
It's
different
like the
elevator music for
royalty
going
free.
up and down?
Okay. We need to connect to Octo now. I hope it's booted. Octo local.
At Aaron Knox, I can play everything on my guitar, but no one recognizes it.
Okay, local doesn't work. I need to find out what the IP address is, otherwise we won't
Use
go.
the browser, it has a web UI.
Oh, really?
Looney scratches the fondue like a pro DJ scratches the vinyls.
I tell you,
The
my
fact that we
stupid...
haven't made an auto fondue dispenser yet is a tragedy. Bitluna's wrist needs a rest.
This local addresses,
a new
they
IP
don't
thing
work.
would be helpful now.
Mesh repeat. Oh. Okay, what kind of... No. Okay, Raspberry Pi. Okay, there is an...
It's part of a riff by John Mayer.
Oh, really?
Time to hack Bitloony's network so I can help him connect to the Pi.
It doesn't show on Wi-Fi. Octo... Oh, yeah, here. We got it. 65 is the IP address. No, not loading. Is there like a port number for that? Oh, come on. I can't paste? What?
Show us your WPA_supplicant conference winking face. 5,000. Try SSH.
What is pi?
I put an SD card in my pie and the wife said it tasted a bit funny.
What? Okay. Enough with this music already, sorry. Okay, we should be able to run this. Oh, Octoprint server is currently not running. Octoprint, oh
Time to exploit log4j on you.
What are you talking about? What's happening here? Oh, I can't open Discord. Someone
Wow, the performance looks great. Good luck with Octoprint and webcam streaming.
Yeah. It's starting. What? Is this some kind of Turing implementation, like with infinite
Have you not
takes?
heard about the log4j vulnerability?
No. What?
Seriously, so many customers were approaching us this week after CERT raises severity for log4 shell. Which Raspberry Pi model is this?
0W1.1.
You didn't? Worst vulnerability ever.
What?
The 0 is not recommended for Octoprint.
And this is something you say to me after whatever. Ages of...
Pretty sure they recommend specifically against it.
Oh,
000 in the bin.1. The most common words in super high-speed computing are please wait. We told you.
Ah.
We just like to see you fail slightly smiling face.
Thanks. I can just take the SD card and put it in an Raspberry Pi 4B or what's the one? But I don't have Wi-Fi on the other one. How do I stream?
Give the old girl a chance.
Where's my Raspberry Pi 4? I have one here. I should have one here. Yeah, but this one doesn't have Wi-Fi.
It says it on the download page. Grin, the UI has loaded now though, but it will be sluggish.
Okay, access control. Start, next. I don't need like very high performance though. I just need to check from time to time.
The docs says Octoprint doesn't work by a male operator wearing female trousers and shoes.
Thanks. Okay, this fondue is a fail. Might be the first one-day challenge that fails.
It just needs to go zoom
Ah.
$JNDI LDAP://sniff122.txt/command/hack.
What do you want? Create account. Okay. Whatever that means. Oh no. Look what it says.
Bets on how long it takes Bitluna's partner to come down looking for her shoes?
Failed prince. Oh no. What online connectivity check? What do you want from me?
Huh? RPI4 has no Wi-Fi? Really?
Oh, I don't know.
And her wine.
I think this was like, is this, I don't know. I could try it though.
I've got 2 legs from my hips to the ground, and when I move them they walk around. RPI4 has Wi-Fi.
Oh, okay. Wait a second. I check what version this is. Is this? It's RP4 Model B.
Hey, it says the 02W works. Just get a marker pen and write a number 2 on the pip.
Okay. What is this connectivity check?
Okay, time for POV project. Ha ha ha.
What is this connectivity check?
Press the test host and port button maybe? A SD formatted for Pi 3 work on a Pi 0? Basically checking if it has an internet connection.
Okay.
Ignore it, uni. You don't need it. It says what the connectivity check on this exact page.
stupid. Okay. Blacklist processing. What's blacklist? Yeah, whatever. Oh, yeah, okay. I think I need that. Because you trolls will...
Are you really going to continue trying with the Pi Zero?
You know what? I can basically take the SD card and put it in this one here. If it doesn't work well.
You don't need that H backquote L.
Oh man.
Then we won't need a USB hub for Pi 4.
Nozzle diameter.
Sorry,
No.
can a SD formatted for Pi 3 work on a Pi Zero?
I didn't pick the Pi during the setup, I think. It's just a generic. Yeah, whatever you want, finish it.
Press
already.
next. Don't care about the details.
Yeah, but I tried to press next and it's mandatory, so you set this up. Okay. Let me check the camera. Where's the camera setting? How do I set up the camera now? Is this some kind of a plug-in?
If boot partition is big enough to hold all kernel images for the different chips, then yes. In settings. The webcam feed is in control. Latency is only 2 light years, not bad. Let's keep going.
Yeah.
Control tab.
Oh.
The spanner. In setting, Looney. The wrench on top.
Settings. Oh wow, that's a lot of settings here. Webcam and time lapse. Enable webcam support. Stream URL. Where do I get the stream URL? How do I set? I have a USB cam connected there.
The default address is okay if it's connected to the Pi. Usually it is the standard you can go with. This is the stream URL from the Pi itself.
The webcam isn't recognized.
Let's watch Octoprint tutorial on YouTube together, Looney.
YouTube. YouTube.
The Pi needs some cream.
How do I see if the camera is detected? Okay, Linux freaks, tell me.
It's worker reboot. Mine glitches all the time. LSUSB. SSH into ANC. Check if the video device is there.
Okay. LS.
Cameras show in dev video.
This is not a command. LS. Wait, what? dev USB. Ah, there's.
Boa
Sorry.
LS La Dev Video. The USB hub ISNT even being detected.
Okay, so like that without. There's no. Is there a video? Video 0? Video. There are like. Oops.
Mu LS USB T.
LS USB minus T.
LS USB didn't show the USB hub and DIDNT show the camera. It is not connected. It's that crappy USB Type A to micro adapter by Charm High that causing it to fail. Hi.
That's a good one. That's a good one. Maybe I should try another USB hub.
Which port did you use on TH0? https://community.octoprint.org.
O2G adapter.
There is no video. It's serving 10 years for killing the radio stars XV. USB OTG adapter.
Okay, let me do that. Okay, the session should be dead now because I try a new configuration without Okay, here we go. No hub in between. It's just.
I think we should use the RPI4.
Okay, we will
Remember
try
the
it.
USB host port is the micro USB on the left with the sock facing up.
Left, there are only 2 USB ports. Let's try rebooting. I think this session should be dead. Yeah.
One is for power only, I think.
Yeah, it is.
Only one USB port can be used for external devices. The other one is power only, slightly smiling face. One USB port is power only and doesn't have data lines connected.
I know.
When in doubt, reboot.
What? Oh.
Wrong user.
Shoot. What was the IP address? 56? Ah!
Has bitluni already forgot the password?
No, it's the wrong user. Was it 56?
Did you switch it on already? Turn it off now.
No,
and
what?
Looney, so it works now.
Yeah. What was the IP address again?
65.
65, not 50.
65.
Thank you. Okay, let's load this.
65. It's still on screen.
Oh yeah, true.
192.168.178.65.
Okay, thank you. Thank you, thank you, thank you, thank you, thank you.
65.
Thanks. How do I create? I want a new, no. I want to create.
69.
Oh no. Yeah, whatever. Okay, pi.
Hex 41.
Here we go. What was the last one? LS. Let me check.
65, 65, 65 Zoo Lane.
Okay.
New challenge. Move 3D printer next to fondue and use that camera at done.
Okay.
Move on to challenge 2, a snowplow laser quadcopter.
The hub didn't work.
Is there a large cat in the background trying to throw up a fur ball? LSUSBT. Yay, it's detected. Succeeds, sort of.
Oh, we need to set up. How do we change the frame rate?
Yay.
Because we got this flicker, this 50 hertz flicker now. Sort of failed it. Yay, it's detected. Now we can't control, because we don't have a hub, we can't control the printer. Semi-success.
Poor.
Will it annoy me every time with this message here?
I think it's pi 4 time.
Why? It's working.
Now we can solder the pink lead.
Yeah. Okay. How do I set the resolution and the frequency of the video stream? There should be some kind of... Do I need to recompile the kernel for that?
Wasn't there a memo on the Octoprint site saying it was no longer compatible on the 0W? There might be a config for that, but never needed that. The 0 is so slow, when it send print commands it's going to skip loads of beats and make your prints look like Swiss cheese. No, it's time for pi.
Okay, but we still need to configure it. So please help me setting up the stream parameters. I can only set the aspect ratio here. Advanced options maybe?
No.
No. I will...
Isn't Swiss cheese what we wanted before for the fondue? I think it's a file int boot. The Wencam daemon itself is not configurable from the web UI.
Yeah, okay.
You may need a different disk image for Pi 4. Might be wasting your time.
Oops.
I think there is a config file on the boot partition. It is.
Oh, there's a boot partition. Oh no. How do I...
You need to do it in one of the files in the FS. You need to do it from your computer via SCARED adapter. CD boot. Reader. m/boot/octopi.txt. Bloody autocorrect. You can tweak the boot in Windows. Nano. Let's not make Looney suicidal. Not needed, just CD boot. nanooctopy.txt. Just vim the file and reboot.
Oh no! How do I exit now? Oh no! I'm locked in Nano now. Can I use the mouse?
Control plus X. CRTL plus X.
Whew. Okay, it wasn't Nano, it was Vim then.
It says on the bottom, Control X.
Okay.
Control X. Control X.
Okay.
Control plus X. Even my shoe rack has a boot partition.
Okay. What do I need to configure here? Which file?
Control X.
Okay, which file? Which file?
Sudo nanooctopy.txt. Control X. How to generate a secure password, put a Windows user in front of Vim. You need a filter for repeated TTS before you go mad. Octopy.txt. Alt Control Delete H backquote L. It is you that made the TTS monster Looney. Are you feeling it?
Alt, Control, and Delete? What?
Control plus O is for saving.
10 FPS? But 10 would be okay. I need to set a shutter. How do I set the shutter? That's not...
Camera underscore USB underscore options H backquote L.
Where? Here, but how do I set the shutter on this parameter?
Control plus XY enter will save and quit.
Wait.
Found on web, max FPS on Raspberry Pi Zero with CAM 1.30 and the maximum frame rate is 90 FPS, but that is only at 640 by 480 resolution.
Okay. I think this is 720p.
There is a web link mentioned in the comments above the option.
Oh yes, true. Oh no! Oh, Aaron! Thank you very much. Thanks for the Christmas present. Yeah, oh no! What did I do? How do I copy that? Okay, camera USB options.
You can buy some earplugs from that donation.
Yeah. Thanks.
Number 2. Think before you type. We trust you have received the usual lecture from the local system administrator. It usually boils down to these two things. Number 1. Respect the privacy of others. G. Option 22.
Option 22. Oh, I'm really... Okay. So we have the Logitech. What's the name? Logitech. C170. No, it's that one here. VGA F10. What's the version number? Let me check that. Oh, something crashed here. The wall crashed or TTS crashed.
Next week we do option 22.
That's
No, disappointed. I think we have determined no one knows in the stream how to configure Octoprint, so you're on your own, bitluni.
Oh, thanks. What does it say? It doesn't say the model number. Are you?
And I would change option 22 to Looney's choice because it is Christmas.
You know what?
All of my new products will include option 22.
You know
No,
what?
no, 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 no.
You know what? We are done already. So how do I access the stream? Wait, it's not the right one. What is that? Where is my... No, this is not the...
I prefer option 42H _L.
Where's my... Oh, this one here. Okay. Option 20. Yeah, okay. 40 option option 42. Okay, how do I access the stream?
At bitbastili, Looney does not need log4 shell to mess it up.
Webcam action stream URL. Okay, so we need this here. Okay, and this is what we just add. Okay, there is no shutter option, so we need... Okay, we add this.
Option 42 is the answer to everything.
Okay. Browser. I just add a browser, new Octocam.
Never fear, Simple Trollectronics is here. 666, the option of the beast.
Here you go. This is your stream, mates. Oh wait, can we just access the stream URL? Wait, huh? Webcam action equals stream.
Add a crop, upside down.
Yeah. Why do we have like this frame around it? I don't want the frame. This is the stream.
No clue, just add a crop in OBS.
Yeah, but we can also set the
The
browser
frame is
options.
option 22.
Yeah. Okay.
Just crop it in OBS.
Margin 0. No. That's not how we do things here. Oh yeah, it is. 640 by 480.
#OBS. I don't see a 3D printer in the video stream.
Go. Here you go, peoples. This is your new home. Here. And I could even change that. Okay, let me move that thing.
Now move the camera. Woo.
Yeah, I moved the camera now.
We lost our POV fan for this. No pink LED, worst stream EER. Select
Oh,
option
wait.
11 twisseranslate.google.com
Yeah, let's...
user agent 32 Spanish pesetas HTTP client connection close street W2 less than J CJV ed BI at dollar a sow die 8. You need to print something now to test it.
Yeah, we do. But first we need to do the LED, it's mandatory. I didn't make the rules. Let me close that.
No pink LED, worst stream ever. Hello all.
Hello.
I vote to print a wedge of Swiss cheese as it going to look like that anyways.
Okay.
I hear a user agent.
Okay.
Hello DIY in the GETTO.
Here we go. Oh, the colors. I love it. Let's destroy a perfectly fine Raspberry Pi Zero. So we just want to replace, what was the LED? This is the LED.
Adam Bryant and Johnny Bergdahl.
Okay.
We should replace the LED on the RPI4, right? Come on peeps, share the love, one like, need some festive donations, dig deep. We aren't destroying it, we are upgrading it to be a supercomputer.
Okay. I need my tweezers.
Press like. More flux, better job. User error, 2 less flux.
There is plenty of
flux. Are you
flux.
using a micropooler flux.com user agent, 32 Spanish pesetas HTTP client connection, close 0 LAME3, die. Buy some ceramic tweezers, they won't get hot.
These are not getting hot as well. Come on. I'm using only a subtle. I'm only using a subtle.
LAME die in the user agent LMFAO. Huh? That's only a minuscule fraction of a micropool.
I don't want to burn everything.
Your TTS is talking bullshit again. Check the private message I sent you on Discord.
I won't check Discord now on stream.
Ha.
Maybe later. Come on.
That is high temp silver solder.
Yeah, it looks like that.
The LED is next to the flux capacitor. Hua hua hua. Me talking bullshit, I'm just reading out what you tell me.
Looks like it's really not.
The TTS bullshit is the only thing making sense. When in doubt, use more flux and turn the airspeed up to blow all of the components off the board.
Yeah, that's not
Hot
what...
air and a plastic connector is a bad idea.
Yeah, I know,
Just
that's why
solder it to
I
one
don't
of
want
the
to crank it up.
GPIO.
Don't want
Crank
to...
up the temp.
No, if I crank it up, we will destroy the connector. Okay, I will try. Let's do 330. Oops.
Put Captain tape over the connector.
Oh, that's a
Can
good
you
thing.
use regular solder tip?
Yeah, I could use solder. But I will protect it. That's a cool idea.
Solder it to the GPIO. Just the tip. Looney will soon go loony at the electronic lady and address upper. Leave the LED on the board and stick some pink filter tape over it.
Oh, the tape stinks.
Now the tape will burn.
It stinks.
That's not KAPTONTAPEN 2022 1959 LS XV. Weird looking Captain tape lol AKN4 expire LS XV. Crank up the temp to option 22x.
Oh, you guys are hilarious. I'm very stress resistant. Very stress resistant. Peoples.
Burn baby burn.
I will basically add some leaded solder here.
Just stick a good old blob of solder on the iron and swipe it off. Slightly smiling face TTP only. To desolder that LED you should heat up from the bottom lunate only. Stress, 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 stress.
Okay.
Put some tin foil over the connector bitluni. Get out the
Bitluni.
pink nail polish.
Okay, now we got a problem here. Okay, that's gone. Okay, what direction?
Well, that worked.
Let me check if we see what...
You shorted 2 resistors, no? Super chat alarm.
Oh!
Here, have a $5 for some
What?
Captain tape.
I got Captain Tape. I got a spool of Captain Tape. Lewis, you should keep your £5, but thank you very much. Look at this. This is a complete roll of Captain Tape. Okay, I hope...
I am wondering how long before Looney disables TTS.
Ah,
Thanks, Sniff.
okay, I need more flux for that one here. Now it sticks to my...
Is TTS driving you loony?
It's driving me, yes. But not crazy yet. You know, it can appear that the...
TTS lady needs an official name. I vote Fanny.
Fanny?
Does Captain Tape have a cape?
Yes. When is the next season of Boys
I
coming
know
out?
a song that will get on your nerves. Get on your nerves at. Now how much have me and Aaron donated together already? LMAO.
Yeah, you're awesome. Man. Okay. I hope it's the right way around. Otherwise, I don't know what else will happen. Okay. The connector doesn't look burned. Let me plug it in, and I hope the pink LED... Should I plug it in on the microscope here?
Amateurs. Meow 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 grin.
Oh fuck. The cable is so
Wrong
short.
LED direction incoming?
Yeah, probably.
Magic smoke.
Yeah. Oh, it's probably too hot or oh
I'm
no.
not donating, I'm money laundering, ha ha.
Money laundering. Okay, I think the thing is still too hot.
If you don't know what fanny means, it's the word it means doesn't belong here.
Okay. It's still quite hot. Oh shoot. It's very hot. I will use Louis Rossman's cool air technology.
Show me your pink, quote from XXX movies. Rapid cool technology, trademark.
Rapid cool technology, yeah.
Rapid cool technology.
Okay. Let's plug it in. Oops. Come on! It's too far away, the cable is too short.
Is so small the extractor sucks it up.
Yeah. No.
Don't worry, we will have a second try with the RPI-4.
Yeah, we will. Okay, let's try again. I will flip it.
It's dead, Jim. No pink, stream failed. By the way, which one's pink? Pink Floyd's The Wall. Movie quote. Your scientists were so preoccupied with whether they could, they didn't stop to think if they should. Is that a camera or one of those USB microscopes?
Camera on a huge ass microscope. Expensive setup.
Don't forget the captain. At Aaron Knox Jurassic Park. No captain tape? YOLO.
No. I need to take care of the orientation of this LED now.
Well done, Adam. Camera on a huge ass? Microscope. Melting connector.
Come on.
At Aaron Knox, I use that phase a lot.
That should be okay. Yeah. It's a little bit fried, but this is only glue residue here. Connector is still okay.
Someone remembers good old times, using soldering irons and stuff?
Yeah.
Yes,
Long time
solder
ago.
surface tension. Is the resistor compatible with the LED?
It doesn't matter really. I would even use it without a resistor.
The connector is still alive, slightly smiling face.
Yeah, probably.
LED looks globular.
Yeah, Dave, it's conversion. It's mandatory. Pink LED conversion. Okay, I think we cooled it down. Now let's see
Donnie
if it's...
Darko's brother just entered the stream. bitluni lives life on the edge.
Here you go. There is your pink LED. Now we can check it off the list. Let me show. Okay. Well,
Pink LED, yay.
oh, what did I do? Oh no.
Yay, pink LED. Okay, credibility recovered.
Credibility
Now the zero
recovered.
feels a lot faster. Wait, is that a dead pixel I see on the microscope?
No, it's not
Play
a dead
success
pixel.
music %9HJ dollar plus W1 UC1 X6 carat E tilde pan XRN.
Oh, we need to fix that. The TTS bugs. Okay, SD card is done. Upload image is done. Pink LED is done. Setup Octoprint, more or less done.
Is it supposed to blink like that?
Notify over TTS. Okay, we didn't do... Yeah, it's supposed to be like that. Okay. Conversion
now we
done.
don't need to fix the TTS bug, it's funny.
Okay. I'm glad you like it. Let's move it to the other one, to the printer.
Yes, it blinks with SD card activity. Challenge 2. Allow use to specify language as part of the fail command should be 30 minutes work and a cool feature. Don't listen to sniff. User agent TTP confused Delta region identification fail. Lang equals Chinese hello world.
How do I mount this here?
User agent Mozilla 5.0 x11 Ubuntu Linux x86-64 RV 95.0 Gecko 20,100,101 Firefox 95.0 N VAS IST DAS. Hello, new here.
Okay, I will use... magnets for the wind.
WAST IST DAS. Lang equals Klingon Kappa. Mic off again. This is Octoprint communicating through TTS. I'm running on a museum piece. Help MEP. A message from my IP.WTF. Your fucking IP address is
What are you reading there?
135.196.99.
What are you reading
Is
there?
all this TUV certified? 1.
What? What are you reading there? When I'm gone. Oh. That's not the image that I... Okay. Let's see if we can get the Raspberry Pi showing anything. Where is it? No.
bitluni just heard your fucking IP address and ran in LMFAO.
What?
Time to ban sniff, road, your fucking IP address and ran in LMFAO. Sniff is sniffing an IP address.
Okay. No swear words, please. Okay. Is the stream working? Okay.
For legal reasons, I have to say that was a joke.
Okay.
Ban sniff from TTSH _L.
Ah.
Thank you, no swear words.
Oh, how do I let it update? Okay. Does it do anything?
If Wi-Fi signal is too low, there were some empty solder pads for an external antenna. Well,
Okay.
foo beep, no swearing. Only things like what the beep you beep and why the beep are you beeping on my beeping stream.
You can use F.
This is acceptable.
But
Next
not...
click equals stream offline. Oh, now we are the correct way up.
Yeah, but is it animated though?
B. We need a winker katza. EHHEHHEHHA.
Sure. No!
Let's say it moved when it didn't to confuse bitluni.
What's this? You can see that
PURPLE power. May I propose a moving or blinking think on the camera view? Loony, your ping PNGs are melting.
No, it's not updating, is it? How do I make it update? I think it's not updating.
Does that printer print upside down? You
No,
have to
no.
order a winker katza. Keep spamming F5. bitluni didn't tidy his desk, he just moved all the crap onto the 3D printer table. Out of sight, out of mind. 3 SPKLs XVX. Is the cam window in Octoprint updating? IG. UFPLs XVX.
Let me check.
Now it is live.
Oh, I need to see the screen. I don't see it over there, so it's a little bit hard to say if it's updating or not.
We can see noise moving. Why doesn't that printer have a pink LED? What is this?
Oh,
Is
it's
that camera
moving.
made by Charmhigh?
Oh,
Try
why?
adding a VLC media player source with the address rtsp://arparip/live@cnplsxv.
No, it's
Watch
moving.
your own live stream on your mobile phone.
This is terrible.
3.5 FPS.
Yeah.
Just 2 hours delay, no worries.
Yeah.
Mic dead.
What? No. Mike. Oh.
Your mic just switched over to room mic. Your own mic seems off host. Translate.google.com user agent 32 Spanish pesetas HTTP client connection close BC caret.
The Spanish
Wait,
pesetas
bitluni is in
funny.
2 places at once. He can time travel. This
Yeah.
is a quiet printer. Check your microphone +2 plus places plus Ls XV.
Spanish pesetas is funny. Sorry. Ah! It's doing something.
32 Spanish pesetas.
Yeah. This is a test print. Ah, it's good enough to see what's happening there.
Fanny has COVID at the moment. She's going crazy. OBX, it is working. And a partridge in a pear tree 3. It's alive.
It's alive, Jim.
I love the 32 Spanish pesetas. Now we can have a look from a safe distance.
Yeah. It looks a little bit dusty over there. I certainly need to clean that mess up.
Please someone donate 32 Spanish pesetas. ESP 32?
Yeah, there are
This
no...
very underwhelming. Also, took me 5 minutes to set up here. STM 32.
I think there are no Spanish pesetas anymore. It's all Euroland now.
Next week's project, a 3D printed duster.
Ah, this cheese
Now
is
you
terrible.
can print biohazardous materials. GBP for the win. How will 32 Polish potatoes do?
Yeah, the Polish potatoes is
32
great.
Spanish pesetas.
But 32 Polish zloty is a lot of cash.
Mark my cheese words lol. What does that QR code do? It's all Spanish euros now.
I don't know. Maybe it's the identifier of the printer. Okay, I'm done with the cheese.
Not bad for an officially unsupported device.
Yeah, at least we are only streaming
Time to
the
scan
camera.
the QR code, slightly smiling face.
We can replace it by the bigger one anytime. So I don't really mind. Okay. Is it printing though? It's just smearing something around there. I can't really tell.
What is next?
IoT controllable. I think we leave it for now. I would rather go like fix the TTS.
It is moving dust. Do you use Home Assistant Looney?
No.
Or you don't care about that stuff? On close X.
I don't really use.
Ha ha, no filament.
Oh. No. Is the filament broken? Let me check that. Yeah, the microphone is charging right now because.
Looney, if there is a project of your choice, what would it be?
Oh.
Or sticky nozzle.
Yeah, I think I checked the nozzle there, and this is a print that we don't even need. So.
Ghost print.
Ghost
I think you need to put filament in the printer before staring a print. Aha, the first problem the camera has found. I'm halfway through doing the YouTube chat API and TTS over MQTT in Node-RED.
Okay.
How do you get print stick to glass bed? It doesn't work for me.
Okay.
You need good Swiss fondue.
You know
Camera
what?
got laggy.
I just turned it off. Okay, so we don't need the print. It was just a test. The print head is too low, so it was like scrubbing.
Are you working with transparent filament?
Invisible filament. So extruder would skip steps all the time because it wasn't able to push out any filament. The printhead was too low. I don't mind. Okay, the streaming of that works now. We can monitor stuff when we have something that we need.
So basically you are scraping your bed like we were talking about yesterday.
Yeah, basically that's what I'm doing. That's like a very shabby project today. What I would like to do is maybe, okay, I don't want to cut the stream here somehow. We fixed the Raspberry Pi Zero. It was a quick one.
FPS drops if there are more than 10 pixels moving.
Really? Yeah, what I would like to do is maybe fix the compression for the streaming on the LED walls, so we can continue with that. And what else? I can maybe share stuff with you. Let me share some stuff. Microscope. Screen capture. Oh yeah. Where's my... Oh wait. Before I screen capture anything, I can maybe show what I did last time. Lab tour, no lab tour today. No lab tour. I will update you with the stuff that we are doing here. Next generation Pi Zero Cam, fish tank cameras. What? Okay. Oh.
The pink LED is useless if we can't see ITIN equals Google CL's XV $. The bodies aren't hidden, no tour.
Yeah, I need to hide the
Next generation
bodies first.
of Pi Zero Cam. Fish tank camera sub T equals TWOB and TTSSL's XV. Live
Okay.
lab tour.
No.
bitluni. I am halfway through doing YouTube chat API and TTS over MQTT in Node-RED.
Oh,
Now
really?
we need to get 32 Spanish pesetas. Fail not working?
Okay, you always became. Okay, so you remember the levitator that we did last week here? Where is it? How do I? Oops, sorry. Okay, and we had this phased array project going on earlier, and what I was doing, I was developing a new board that I ordered yesterday, 7 a.m., 8 a.m. So by next week, Tuesday, we should have new boards. And I hope that I'm able to to edit anything for Christmas. So many breadcrumbs in my keyboard. Sorry, it was loud. I love it, levitating styrofoam. Yeah, and I was basically designing circuits to accommodate, since my LCSC, I showed this yesterday, my LCSC order of 10 millimeter, oh, let me show that in big, of 100 ultrasonic transmitters.
Failed.
No, it's
No fail?
it gets stuck somehow. Okay. Look at this.
Failed.
Yeah, it's probably
Phased
rebooting.
array project.
Okay, yeah, phased array project. And these are they're really...
bitluni sets up Home Assistant now.
No, not home. You asked me what I want to
LED
do.
wall LMFAOH backquote L.
Okay, so look at this. This is the size comparison. And the data sheet says it's the same power, but I don't trust it. But I got 10 millimeters because we saw in our simulator that the wavelength aligns way better if we have a distance of 10 millimeters between the transmitters. So let me get this on the screen. Phased array code simulation. Okay, here we go. Okay, so this was...
Now you can make a hoverboard.
Yeah, a hoverboard. Yeah, that won't work. Okay, distance. This is like with 21 millimeters distance. But if we pick that, I just go down to, so at 40 kilohertz, we have a certain wavelength, and look what happens. This is 10 millimeters.
I'm guessing that's 10 millimeters between the center of the transducer.
Yeah. Yeah, that's just the distance of the array. And this is the frequency. So if we would change, like, let's say we get 16 millimeters, the wavelength doesn't align very well. It would be even better. Okay, this is like the best power distribution.
Looney, I was kicked off the stream. Did you explain what your project of your choice would be?
Yes, I did.
Make cheese levitate.
I was just explaining a little bit of what I did for my phased array project. And this is the thing that I would do next, the streaming compression for my LED walls. So let me show that. Let me show you again. So I got like 110 millimeter transmitters here. This is like for an array, and I got 10 millimeters because with 40 kilohertz it aligns better. So we get a better alignment. We could go down with, I think 39 is also okay. So we get even a better alignment here. And 24, yeah, 24 won't work. 24 is like, this is 24. It's really the wavelength. We get like a better alignment of 40 again. Yeah, that doesn't change. So if we would go down to, let's say, 20 kilohertz, which is, for me, it's not audible. For younger people, probably, maybe. And if we would go there like down to 20 millimeters distance, or even, this is nice concentrated. So even like here, 10 millimeters would be the best. So the lower the frequency and the lower the distance, the better the alignment of that is. So we got now 10 millimeters and 40 kilohertz. And now just rotating this, like scanning with this ray, would be just adding like this slope here.
That's not 24 millimeters, that's 24 centimeters if that is in meters. Try 24 millimeters.
Oh, you're right.
Play some bitluni music.
Oh no.
And you have a slider for your frequency?
No, I don't have. I can change that. Oh, you're right. You are right. I'm a failure. No. This is not like...
No.
Oh no. Okay, but we can scan. Look at this. This looks cool. And we can basically scan it. Maybe I should make this slider scan somehow. Can concentrate the ray. This is the other direction. And we can basically set the angle to any of these. No, this is like, oh no, 21. And what's 10? This is 10. Oh no, 10 is 10 is too low.
Ah yes, units catching you in the butt.
No, 10 is too low. 10 millimeters distance is too low. No, let me check that again. It's normalized. No, it's not concentrated at all. Oh no. Okay, let me check. Yeah, 60, 80 kilohertz. Oh no. 100 kilohertz? No. Terrible. Oh, 400 kilohertz. Look at that laser sharp ray here. That's cool. Okay. So we are stuck with this design now. Oh no. Okay, maybe we can compensate.
I just crushed all of bitluni's dreams, didnti.
Yeah, you did. Okay, let me turn that one off. Maybe we can compensate with some kind of beamforming here. No? Look at this. It's neutralized. What if we do that? Okay. Okay, so I might want to change my design for the next round. Shoot. Okay, if I do like, what's the diameter of this here? Might be even cheaper. That's 16 millimeters. Let me check Mauser. Mauser is not loading. I turn off the cheese. I have enough of the cheese today. Oops, transmitter. Uh-oh. What was that? First thing to do is in stock. Oops. In stock pricing. Oh, wow. Okay. Now we have diameter 12.5, 16.5 millimeters, 16. That's with the metal can. These are the type. The 16 is that we know, the one here. $37 kilohertz. Oops. Okay. Oh, TTS is
Go
broken.
down to approximately 37 kilohertz.
Yeah, 37, but we lose like strength, raise strength. Oh yeah, we lost the Raspberry Pi Zero here. Okay, let me check that. Where's the Mauser? Okay, we have 16, diameter of 16 is the... Oh, look at this, the bigger ones are expensive. TTS is broken.
Fail dead?
Yeah, probably. Okay.
How would piezo buzzers work for levitation?
I don't
You
know.
are at 0.1 centimeters.
So what this year they have a horn inside. I don't know if you can see this. There is a horn inside. So that is like maybe glued or like spot welded to the piezo. So this basically amplifies in this direction. I don't know if I even have piezo. Sorry. My microphone is charging since you are connected with the other one to the TTS. Oops, sorry. Okay. So I have plenty
Mike,
of these here.
I think the horn is glued. I've had one fall off in the past.
Oh, really? Okay. So I have plenty of these buzzers here, which would probably also work with that. Huh. And this here is also like a buzzer, piezo buzzer.
You should have the LED wall default to the first frame, so then we have the bitluni staring into our souls when you aren't in the way. Yeah.
Okay. So let's check that out here. So I like this one here. In stock, apply filters. So the 16mm device, and this is the T80. This is this transmitter. Let's check the data sheet so we can see what's actually. Oh, it
Looney,
crashed again.
redo your interference pattern. You were at 1 millimeter, not 1 centimeter.
Yeah, I know. Ah. I'm going to leak my address again. On Mauser, you think? Okay. Look at this. Okay.
Do piezo buzzers output higher dBs?
I don't know. Didn't try. I don't think so. Maybe they are optimized for the audible frequencies. Still 1 millimeter. Okay, 100 centimeters. Okay. Yes, so it is 10. This is 1. So no, so we are right. This is, someone was confusing me. 4 kilohertz, this is 40 kilohertz. No, it's everything is all right. But if we do the distance of 16 is not beautiful. 37, let's check. 37 is not beautiful. Yeah, 10 millimeters. Okay. Yeah, so I was right. And who was wrong before? Who was it? Okay. You're just confusing me. Where is the window? Here. Okay, let's check our possibilities. Look at that chart here. You can see what the sweet spot is. 120 dB is somewhere close to 40 kilohertz. It's not precisely 40 kilohertz, but somewhere close. Then we have the directivity. You can read here, like 90 degree, we have minus 30 dB. 0 here, or yeah, this is 0. It's basically, yeah, imperial. Okay, this is the packaging.
And the guys using imperial are confused totally now. Not us. 10 millimeters is 0.01 meters.
Yeah, 100 centimeters is 1 meter. Okay, so I did a schematic. This is not the right one. Phased array schematic. Yes, wait, here. Okay, this is like, this is only one with 35 transducers. 35. I show you how that would look like. The array. And I don't even know if this driver will work. This is something that we need to find out. So here is the design of the array, and then we have the layers. This is like, let me mark that so we see how many. These are 61. This is a configuration of 61 transducers, but we wouldn't have enough like it's hard to control 61 at once at frequencies of 1 megahertz probably, because we need to change the phase for each individual transducers. And this is now the version, oh, 37, it's 37, sorry, I was wrong. So I was thinking of using for that, where is the cable? Didn't I pick the cable? Okay. Old hard drive cables for that, 40-pin hard drive cable, and basically use like 1 pin per speaker here. Okay, so the driver that I picked, please don't order all of them from Mauser, because I still need if I please, pinky promise you don't steal the driver, because this is still affordable somehow. Affordable motor driver. It's this TC78H621FNG. It has phase A, phase B. It has 2 drivers, two built-in H bridges. Maybe I can show that. Can I copy the value? Yeah. Copy the value and show off. I was searching for hours to find the proper driver. I still didn't test it. No, was it this one? Yeah, I think that's that one. Card is full. Okay. Okay, look at this. Current 1.1 amps. We measured last time with this year about 120, 110, 120 milliamps at 30 volts. So then look at this. This is the circuit. You have the motor logic, pre-driver and H-bridge. 2 H-bridges. It's basically made... Okay, you have a... I don't know if you can... No, you can see this. How do I turn that off here, this side view? Those matrix amps. Yeah. So you have this voltage, motor voltage, so you can control them with different voltage, and of course like 2 H bridges. And this is the pin configuration. These are the ratings. 18 volts input. Oh wait. Is this the one that FNG? I need to check that. I thought we had like 30 volts plus minus, but we are running it in push-pull. 18 volts will be 36 volts total. Let me check that. FNG, yeah, that's the one. Okay, I would love it if it was more than 18 volts. But here controlled power supply, so we can run it from 3.3 volts and 5 volts as well, so the driver is compatible with both CMOS and TTL. No, CMOS, and yeah, good. Okay, power supply. and it operates at 500 kilohertz. This is the most important thing. So we had the problems with the H bridges that I had here. Where is it? H-bridge driver that didn't work last time because the switching frequency wasn't high enough. And I can find it. I can find it right now. The switching frequency was too low. But here we have, okay, let me check. Hysteresis, input consumption. Do we need to see this temperature? Okay, so this driver does the transition for us. We only need to send, here, we have a standby if we want to use half steps and so on, turn it off. But we only need to send high and low. So it just flips the polarity with high and low for enable if this is high. And we have the main standby pin which turns everything off. So we need only one pin per speaker or per H-bridge, one pin to flip the polarity of the transducer. This is great because we want to control them in parallel for now. We need a switching frequency of like to control individual speakers at like very fast. The faster the better. So this is full step, half step configuration. You can see this is just saying low, low, high, low, high, high, low, high. This is if you can control stepper motors with that. And these are half steps if you use the enable pins as well. And this is the most important thing. So you can see here that the switching here, this is the output TR. This is the ramp. TR is 20 nanoseconds. Crazy, isn't it? The delay, this is if we would control it, like if we have like a control loop where we maybe detect where the ball is and we adjust like PID or whatever and control the whole thing, the delay between the input and output would be relevant, but that's only like also 500, that's 2 million times a second, like half a microsecond delay only there, and we have 20 nanoseconds ramp. What's the voltage for that? It might change with the voltage, but it's insanely fast switching here with that one. Transistor current. And these are the configurations. We can drive two transducers from one driver IC, and we could also use like a stepper motor here. Yeah, it's a nice chip. Toshiba, it's probably around for ages. That's why it's still more or less affordable, even though it's like, okay, at 250 we get it for a euro from Mauser. So I guess you can get it cheaper from elsewhere. And this is my circuit. I showed you my circuit that I designed for it. I added a cap for the voltage here. 100 nanofarads. I don't think this is really necessary. But what I'm doing is enable A and B. I connected all drivers to the same pin right now to save pins, and have just one pin per thing, and I have like one standby pin. So I can turn off and on the whole array with the standby or enable pins. And otherwise I just control like flip back and forth with the pins that I control. This is like a 40 pin, no, this is the 80 pin connector, which we don't have. It will be probably 40 pin at the end. This is to connect to the speakers which aren't here. Ignore that one. This is not the design that I'm testing right now. So the design that I want to test right now. What if you use an inverter between inputs, so you only need one connection? I only need one connection because the driver does everything for me. I just need low or high, and it will basically do the low and high with the high voltage for me. So the only thing that's on top of that is to enable it, the output. It will be like high impedance if the enable is off and on. That might be necessary if you have like, let's say a speaker, you would have the DC offset all the time. Even though if you want to turn it off, it will swing all the time. If you turn it off, you need to turn off everything. So there is no like state in between where you can turn one speaker off or put it on standby or whatever. They are all swinging at some frequency, or they are put to some kind of level, like either this way or this way. So it has like a DC offset. I don't know if piezo is affected at all by this because it's capacitive. TME EU, what is TME? I will check that. Oops. Let's check. I'm just checking Mauser because I get the parts with the boards delivered from Eisler. Eisler has this like service where you get the parts, all the parts with your project. Oh no, I don't get now. Lighter. Okay, I should check that out sometime. Okay, let me show off. Oh, it's only 10 o'clock. This is so cool. The Octoprint stuff was really easy to make. Okay, I have the array integrated schematic. Where is it? Does anyone know how to copy between sheets or designs? I can't, like, if I use that and then clone, like in copy paste, it won't work between the sheets and KiCad. I hate this because I can't copy the circuits here to another sheet. I need to save the sheet and can't basically change it. Okay, so what I'm doing right now is I built a linear array for now, which is only consists of 8 speakers, 4 drivers. We have a connector to the microcontroller, which controls like 8 bits. So if we're using an Arduino, we can use 1 register for that to be faster maybe. Or if we are using ESP, we can use I2S with 8-bit or 16-bit or whatever to control one or multiple of these here. And we have the screw terminal here for this high voltage. I added some caps up to 50 volts. I don't know if this is necessary. And the board design looks like that. KiCad PCB. Does it open? It's loading here. I worked all night on that. Not yesterday. Yesterday I was in VR chat, but it was the day before. So my sleeping schedule is screwed. Let's view 3D viewer. So this is the board. Okay, this will be the array. This board is only 8 centimeters. 8 centimeters wide. So it will be like this long and 2 centimeters. So not as wide as this part, but as long as this part. And this will be a phased array. And the wiring actually worked out at the end. I put on a huge cap here. This will be the screw terminal. It's just a connector. I picked like the 2-row setup connector so we can use like cheap ass cables like that one here. If we do like the microcontroller board at some point. But we can also just use female jumper. So, and that's the current board. There is not, I think, the other side. This is where the transducers go. And it's very boring. bitluni's phased array. Here. This is... Who had the OCD? Spot the error. See what the chat says. Reading back from the transducers, not with this array. Okay, so I will use this one only for the phased array. This is only a transmitter phased array. So you have like different type transducers. One are receiving, then you have transmitting, and some that support both. And I got only from the 10mm ones, I got only the transmitting ones. And what we can do to receive is basically put a receiver just next to it. We can even use this board just next to it because it will bounce all around the wall. So we only need one receiver here. U3D is not soldered. Yeah, we have, look at this. No, there's no solder. Yeah, and I ordered from Isla. They are shipping the parts. You can assign the parts like for assembly or for precious parts. You can basically assign, and that's basically Mauser. From what I saw, I basically took the parts from Mauser, searched for them, assigned them, and just ordered the boards and the parts with Blitz PCBs. And they said on the page that it will ship on Monday. So I took even UPS shipping or something. I hope it gets to me on Tuesday or at least on Wednesday, so we can assemble that one and make a video. So this will be one of the things. GND Dutch Taurus. Yeah, Lars, it's GND. It's tilted as always. This isn't. Where's my here silk screen? It's slightly tilted. I ordered some voltage guards and got kind of ripped by TME, though the others did not have the parts in small quantities. Okay. Just use FPGA. I have FPGAs. I have FPGAs. I can use FPGAs. Easy solution. Inside the project I'm working. hierarchical. Okay, you know what? KiCad needs to hire a proper UI designer. The usability is terrible. FPGA rabbit hole. Okay, let me check the FPGA options. It should be charged now. Okay. Okay, let me check. I have the Arduino Vidor. How many pins are these? Not many pins. But I have some other FPGAs here. Where's my FPGA development kit? No, that's not that. I think I ordered somewhere. I ordered FPGAs. Should be a sealed bag somewhere with FPGA stuff. Okay, I want, here is some. What is that? No, this is S2. What is that? Oh, I got only ESPs here. Oh, okay. I have like a gazillion of ESPs. I could basically also build an ESP array. The ESP32 supports I2S with up to 32 pins, even though there are no 32 pins, but we can use maybe 24 pins. No, we don't need a current driving. We only need many pins. So, yeah, we can also use like a huge ass STM or something. Or many small AT-Tinys. At least they are not running an RTO, real-time operating system. They just need to drive the stuff. Where are my AT-Tinys here? I got like a box of AT-Tinys and old PIC microcontrollers. Okay, what do we have here? Let me go to the microscope. This stream is boring, isn't it? Look at this. So these are like really old now. I don't even know what kind of microcontrollers these are. This is like really old stuff. Look at this. Look at this module here. This is like pressure, air pressure, BMP85. This is like ages old. Look at this thing. This is really old. Okay. Now we have 80 mega, 128, bunch of these. Some are a little bit bent legs here. Oh shoot, yeah, that's how I care about that. Okay, 4 of these. We have plenty PIC microcontrollers, PIC 5, 4, plenty of those. Then we have, what is this, microchip, or another batch of. We can build stuff here. There's no shortage. This is something. Oh, I think this is like a small PIC micro, 6-legged PIC microcontroller. Okay, what's this? PIC 18F, whatever. Also 4 of these. Then we let's go. Let's check. I might have caused a shortage, but these ICs are like ages old. So Mega 328P AU. So we might have enough of these here. I don't know what this is. This is probably some kind of display driver. No, it's Samsung memory. That's a memory IC. Okay, what is this? Mega 16 AU. Another PIC. What is this? 80 tiny. Oh, I have also some more 80 tiny somewhere else. Oh yeah. HM10, MH11, Bluetooth low energy modules. This is something else down there. Module, what's that? Oh, that's also atmospheric thingy. Yeah, but this here, promising. Or this one here. How many pins? This is like 32 pins. So maybe we can use 16 thingies from that. And they don't need flash. We just need to supply one silicon broker. No, I can't sell that anymore. Let's make a Frankenstein. Yes! We should make a Frankenstein with PIC, Atmel, ESP on Volkswagen. They pay high. Okay. There is no shortage in ESP modules, but I might have also a few ESP modules here. Yeah. Okay, I have plenty of ESP32 modules. I thought I will build something with that. I still didn't. So I think there is no shortage in microcontrollers. Do you have any more timing appropriate chips? What do you mean with timing appropriate? Say ESP32. Is hiding his own stash of ESPs. Yeah, I have some. Oh, I have even these serial USB to serial. Oh, RP2040. Yeah, RP2040. I have some of these as well. Do you think we would use timers for that? It might be an option to use timers. PIO is also an option, but how many? I think PIO has like can only address a limited amount of pins. BMP 280. Yeah, it's the best one. Let me check. PIO microscope. Okay. It would be funny if after all that time we using some really old ICs that I got here. Timers are the easiest way if you have fast and large counter registers. Yeah. Let me think. We could even like, so if I want to control the phase, 16-bit counters, FPGA with delay blocks would be ideal. Yeah. Yeah, but FPGA is like gold right now probably. I can't afford new ones. I have some around here, and I know that I bought some STM32s as well. But my goal is, with this phased array stuff, my goal is to build like multiple of these here. Like maybe we need like 2 opposing ones, maybe 4, maybe even 5 of these. So we need like, how much was it here? 61, 300, more than 300 pins. More than 300 pins and 200 drivers probably. What's TPU? What's TPU? No, tensor processing unit. Looks like layout of Chernobyl's reactor. Yeah, that's the natural way of, look at it. It has like 10 centimeter, it's at 10 millimeters distance from all the neighbors. So this is like the optimal hex design here. So these are 10 millimeters, these here, this, and this. So that will align well with our beam forming. That's why, you know what? If we would get some serious funding, I'm not sure how to get this. Okay, I checked with Alibaba. You can get the transducers, like the 10 millimeters, like 20 cents per piece. We pay at Mauser 3 euros, but I paid like 60 cents per piece now from LCSC, and you can get them from Alibaba for like 20 a piece. So if we could make a wall, a complete wall, the size of this one here, with this ultrasonic transducer array that's formed like that here, and basically modulate audio, spatial audio, where if you stand in front of that, like in one region, and then move to an slightly next to it, you hear something completely different. You can modulate audio on top of that 40 kilohertz. Do you want compact array, or would a sparse array work better? What are you going to beam? Okay, so basically, let me show that. Maybe I can check if I can find. Need to find this video. I show you an example for the levitation thingy. No. Where is it? Okay, I can't find. Well, this is like acoustic levitation. Let me find it on YouTube. I will show you. Here. Let me. Here. This is an array. They're not using a hex array, but basically you can control it here. This is like this configuration. So you can do this acoustic levitation, and yeah, I'll look at this. They're using, oh yeah, okay. So some similar things, we saw similar things last time. Okay, this is cool. You can basically control the position of the phased array. And that's why you need to control every individual speaker, or you need like FPGA that calculates the phase for each individual speaker from the information that you provide to it. And what like if you have or laser speaker, no, it's not here. This here. Yeah, this is basically the same what we see with our simulation. And what they do is basically modulate the audio on top of our 40 kilohertz. That's an FM transmitter, but it's more like AM transmitter, I think. Is it? No, it's FM. Okay. Yeah, but this modulation that happens like in analog, and we can do this in digital as well. So they built a speaker like that. Okay, whatever this video is about. But if you control, let's take our sim here. Freaking supercomputer. Yeah. Okay, let's see. Okay, this is our ray that we get, the beam that we are forming. Let's focus that. what did I want to say? Okay, so if you transmit the same phase to all the speakers, so if we do that here, it will be in the center again. So nothing changed. And what they do, they basically drive all the speakers at once and just change the phase with the modulation of the audio. So you get a ray, a directed ray of this audio signal that you're transmitting. And this will basically, if you direct it maybe on a picture frame or something, the picture frame will sound, will probably vibrate with the sound. Or your ears, if you stand right next to it. But what we could do is, imagine we can use the array to, let's say, modulate on one sound. Say this is the sound that we want to be modulated with, let's say, left ear. This is the simplest application. Left ear, and we modulate the audio with this phases of the frequency, and then we modulate this with the sound for the right ear, or different way around, whatever. But since we are standing in front of that, this would be right ear. So if you are standing in front of that, you should be able to hear different sounds at your location of the ears or whatever. So you have some kind of... I think there have been like a million Kickstarter campaigns about that already. But what I can imagine is, imagine like a wall of these. I think the more of these drivers and more speakers you have, the more like precise you can like direct this ray of audio and so on. So you could have like play a different audio station in a different location of the room, even though if the wall isn't that big or so, it's just like this hex field, but it can project in any direction. You can see it here. It projects in this direction, like it will go further in that direction all the way. So you can project basically audio in different regions of the room. 3D sound projector. It's not really 3D, it's 2.5D, because it's only like you can't like project here a different sound than here. I think this is not possible. It might, oh wait, it might be possible. No, it's not. No, it's always traveling in that direction. It's emitted here. I don't think that we can control it that well. Okay, you can see here it's like not really... I don't think it's possible with a flat array to control it like that. We could control it spatial if we had like two arrays, one here and one there. We could maybe concentrate like in one particular field here, and then you need also one on the ceiling, so like at least three panels, and then you can maybe control it directly in one spot. But then there needs like be free vision. Won't the beam change when the frequency changes? No, the frequency is always 40 kilohertz. What you are doing is, okay, let me do the paint. What you have, this is also like, they make it like FM radio. You can also use AM radio. AM is amplitude modulation, but basically what AM, you have like this audible audio is like this frequency. This is the audible sound. And then you have the 40 kilohertz, which this is modulated on. Oh, let me, this is this like the, and this is the 40 kilohertz, and this 40 kilohertz is constant. It's always 40 kilohertz, okay. Yeah, it doesn't look like it's always 40 kilohertz, but it's 40 kilohertz. Oops, sorry. So what you will, this will always, the 40 kilohertz will always be looking like that, but this intensity will fluctuate. So you would have like, if you do this AM amplitude modulation, you will have like darker spots and brighter spots in here, and this will travel with the speed of sound in this direction. The fail doesn't work. What happened to the fail here? Somehow I need to reset this. Sorry, somehow the reset, yeah. I gave it, I don't hear any fail anymore. Fail, transmits same sound at different delays, so the sound that matches collide at different spot in the room. Yeah, you could do crazy stuff with that. If you like simulate or let's say scan your room, you could precisely calculate what you want to emit, like maybe a moving ghost in the room or anything. Okay, FM frequency modulation is basically moving. It's still 40 on average. It's still 40 kilohertz, but you have like the square wave will be like slightly widened, slightly. It will like oscillate around this 40 kilohertz all the time. So on average, it will be only like a little bit different from 40 kilohertz. This is like frequency modulation in this case. So this frequency, and this is AM. We did this before. AM radio is really like, we have the code for that already. You're not going to have 40 kilohertz if you mix. It's going to be a vector sum. Yeah, probably. I don't know. We can simulate that. Vector sum. We have the code for the okay, let's do a 20 kilohertz on top of that here. So the amplitude, let's do an amplitude modulation. This is a boring stream now. It turned from one day challenge to TTS not working, whatever challenge. I don't know why this broke. It should be working. I restarted the fail notifier. I don't see it working though. Ah, no, sim, that's okay. Okay, so boring part. Render wave. DA phase. And then we need, oops. Okay, distance, sound, math. Wait, what's the sound frequency map? No, this is not what we want. We need to calculate it once. So this is the distance. Oh wait, no, that was right. Distance, speed of sound, frequency, and this is 22 kilohertz. So let me check that. Frequency 40. Oops. Let's say we modulate like 2 kilohertz on top of that. 2 kilohertz would be like, or let's say 500 hertz. So we have 500 here. Phase, we don't have a phase shift on that. And that's phase A. And we do like this what's the A? Oh yeah, that's attenuation, directional attenuation. Okay, so, oh wow, you're right. That's broken as. No, my plans. Let me check that. Okay, we still need the. No, look at this, 10 millimeters. I mean, it's not perfect. So this is like the 400 hertz on top of that. Oh no, wait, it's 500? What did we use? 500 hertz. So this is the result with the 500 hertz on top of that. So we will still hear the sound. Yeah, it's like voice. Mainly here and a little bit here. Yeah, you're right. It's not that perfect. Oh, maybe we need, oh. Okay, 413. Okay, let's do 413. Let's try that. I need to make the default here distance. It looks the same. Yeah, 440 hertz. We should use like an actual audio wave. We should emulate an audio wave that's traveling this direction. Because this will be not constant. This is not like the case of that you have a constant sound like that. It's not a normal case. Oh wait, no, that's wrong. What did I do? This is wrong. We need that. Sorry. Okay, again, it was my fault. Let me just set the default to 1 centimeter. Okay, here. Oh wow, look at this. It works. It works. This is what I wanted to see. This is the audio. This is the 440 hertz. You see like the amplitude. What? Okay. Do we want to change like maybe this is let me check 500. 500 again. Or like random 540, whatever. No, it's perfectly fine. If we like 200, no, let's say 800, then we should see more hotspots. Wait. Here. This is amplitude modulation. Not sure. So I'm not sure if we need frequency modulation. So let's say we do FM, but this is like, oh, this is terrible FM. Wait. Oh, this is already like frequency. No, this is phase. Oh. So we do this. And the frequency is here. So we need to do frequency modulation, phase A. This is only like modulating by 1 hertz up and down. Nothing changes. Times 10. Or let's say times 100. Nothing changes. Times 1000. Oh yeah. Yeah. What is PM? What is PM? Look at this. This is what you meant. It's like that we get a different beam, and since we have varying frequency here by 1 kilohertz up and down, you can see that the beam is like really strange. Phase modulation. Okay, yeah, phase modulation, we can do that. This is easy. Okay, so this is amplitude modulation. Let's make it even like 3 kilohertz up and down. What? Shoot, that's cool. Okay, this should be FM and now phase modulation. So we will basically add phase A. Phase A, yeah, by 1. 1 is almost like, how much is 1? 1 is 30 degree. Yeah, this is phase modulation. Because we have math, we have pi. Pi is 180 degree, and plus minus 1 is 2. So we have like maybe 120 degree. Oh, so it's 60 plus and minus phase modulation. So phase modulation would also work here. But I don't know which actually we need. Amplitude modulation is a little bit more difficult than the other two. And this is, okay, I just removed that. Okay. Oops. Okay, so this is the shape. Huh? What? Oh no. That's the default here as well. Sorry. But it calculated the right one. Okay. Wait, what? Distance, value. It stored the values or what? Oh. What is happening here? Oh, yeah. Display. Okay, here we go. FM and PM. Oh, I have no idea how that works. You are the expert, and we probably will have to work on that together at some point here on stream, because I have no clue how that works. So how do we do amplitude modulation? I think let's make new. What's happening here? Okay, don't save that. So what we are only able to control like on-off states right now. Whoops. Okay, so we have only something like the square wave right now. So the only way, this is 1, this is 0 for us. Now we can perfectly control, let's say, hey Louis, we are working on the phase array, like planning how that will work. A fail doesn't work. I don't know what happened. It's a little bit silent right now. Okay, combination PM to change the angle and size of the beam, FM to superimpose the signal. Yeah, that's what I mean. This is yeah, that's okay. Now I got you. That's what we are doing right now. So phase control, phase modulation is this here, basically. We change the phase here, but this is like a constant phase shift for each of the speakers. If we do it like on the fly, we can do this. It requires maybe some pre-calculation or calculation on the fly, or solving some linear equations. Everything is falling apart. Where's my cat? Okay, so we can control, what is our, let's get back the data sheet. Oops, I need that one here. So this here, this is our control. We have like TR, TF is 20 nanoseconds. I don't trust it. Let's say it's 50. So 100 nanoseconds. We have a 100 nanosecond ramp in total. So I don't trust this. We need also like a plateau. You can run 2 emitters with the sum difference of the FM signal to get the beat signal to give your output. don't really understand what you mean by that. Two emitters with the sum difference of this. I would need a drawing. Okay, let's calculate our best values. Okay, or worst case values. Okay, so we have, oops, 1 divided, or let's say, we calculate in nanoseconds. So 1,000,000,000 divided by 40,000, oops, 40,000, oh wait, what? Oh, did I set, okay, let's do 1,000,000 divided by 40. No, that's 1,000. Oh man. Ah, sorry. Okay, million divided by 40, 25,000 nanoseconds for a complete wave. This is the complete wave. Okay, so we have 25K It's stupid to write it this way. I could basically write microseconds. And this here, the transition here is, I would say, 50. 50 nanoseconds. So back and forth is another 50. So we had 100. Nanoseconds. 25, what, 40 kilohertz is 25 microseconds. Geology, right? No, NS. That's an N, not M. No, it's microseconds. Oh, people. Okay, okay, I got you. You're. It's too hard. Oh man, pencil. Okay, you got. This is my mu. Now it's okay. With seconds, 25 seconds. Okay, try it. So, phase control is really easy. We can basically control it with ESP 32. We can output 40 mega samples. What we need here to output this my brain is not working anymore. Okay, so we need like 50 this 40 kilohertz, 80 kilosamples. So 80 KS 80, oops, 80 kilosamples. I need to, what, this is like mini, really? Okay, let's write again. So we need 80, this is without any phase shift, kilosamples. A new Flappy Bird level design. So we can basically oversample that with the ESP32. Let's assume we were working with the ESP32, which is crazy because we can't do this with an Arduino. Arduino has only 60 megahertz. Yeah, I think Paint is the right tool for that. So we could oversample it like 500 times. 500 times oversampling with the ESP32. Let's mint that. Okay, that one I need to keep. 5. So we can change the phase with like 500 micro steps. It's not the megahertz, it's the latency and throughput. Yeah. So we can, since the slope here is always like this edge, it's always the 50 nanoseconds that's basically shifted, and what's we can basically shift it by we can even shift it like 1,000 steps or something. So we have enough resolution with the ESP32 at 40 megahertz to change the phase in each direction here. So or the location of an edge in each direction. We can change this by plus minus like 500 here, 500 different steps. That's like really cool. So this will be like 40 kilohertz, 40 samples, something like that, in this ballpark. The caveman wrote better on rock bitluni, yeah. So for the phase we have enough resolution. Now amplitude, how do we change the amplitude? We have only a square wave here. Let me remove that. How do we change the amplitude? Oh, that's evil. That's evil. I know how we can change the amplitude. Would the beat frequency effect give you desired hotspots? Yeah, that's what we simulated. We had a, oh no, I removed the code, but it's basically the same. Look at that. Let me reset it. Okay, this is the ray without the modulation, and we did amplitude modulation here times, let's say we have a tone that's 800 hertz with amplitude modulation. Whoops. Oh, no. Oops. Okay, here. And it's still the same, but only the pulses. You can see how the way lower frequency of the sound is just traveling in space here. So it's still the same with amplitude modulation. And we saw basically a slight wiggling in frequency modulation and phase modulation. Wait, okay. Ah, I lost it. Okay. So what we can do to change the amplitude is to basically cheat. We don't have like the silence part here. We can't do like the duty cycle. There is no duty cycle for us. So we can't do something like that here. Shift that high part here and there and here like that. So it will, the power will average out. So this is a, like the, if you average that out, you will get like a lower amplitude here. We don't have the control over that because we don't have like, we have only 0 and 1, except we use the enable pin. But we can only use the enable pin for every driver at once. So if we want to modulate only one sound wave on top of that, we can use the enable pin to basically disable the driving at these points here. But what we can do, we can cheat and leave a DC voltage on the piezo. I don't know what happens if you do that. Might not be very, very cool to do that. So let me remove that. But what we can do, we can basically do that. Oops, sorry. Thicker line. That and go right away to 0. We keep the frequency and the average what we get from that will basically look like that somehow. So it will be basically DC shifted, but we still get the same thing, what we want. There is no, the speaker yeah, there is always a DC voltage. Yeah. The beat frequency is always equal to the difference in frequency of two notes that interfere to produce the beats. So if two sound waves with frequencies are played simultaneously, the beat frequency of 2 Hz will be detected. Oh, this is the beat frequency. So if we do amplitude modulation, no, but it's an amplitude modulation. It's not adding. We don't add at the same time. We modulate one. We multiply the frequencies. I don't know if this is the same with the beat frequency. Okay, so we can do this. This is the easy route. Just change the duty cycle for high or low. Maybe we can switch that from time to time. Or wait. Maybe I have a better idea for that. So what's happening if we are doing that? Like we do the short pulse here, long pulse here, long pulse here, short pulse here, and the loop is complete. No. No, wait. No, not really. The average of that would be no, that doesn't work. NF fail seems to be fail to, yeah, fail is, it died. I don't know why, honestly. I don't know what happened to that. I will try to reset it again. It basically died and the image is still there. Huh? API case, API key, very active. It will reset in 50 minutes. Yeah, you appreciate the quiet time. Okay, it's not a, sorry, not a crazy one. What we could also do is to, since we have 100 nanoseconds, we can do like some fast switching here. Oh yeah, 2 banks of transducers independently. Yeah, I could basically, if I want to, I could use both pins, but then I need twice as many pins. I could wire this. This is not a problem. Can we emulate like faster switching here? Okay, so we have 100 nanoseconds for a complete cycle, and this is 25 milliseconds. So we have 250 pulses. We can basically do 250 on-offs. $250, that's convenient. It's like 8-bit almost. 250 on-offs. Maybe even 256 would work because I was like really generous with the time, the rise time, and so we can basically do like a PWM, like micro stepping there. But how? We don't have a 0 here. No. No. I think we will just use this phase thing. Just use the phase like that. Just change the duty cycle and leave the DC offset. So what happens if we put a DC offset on the piezo buzzer? Does anyone know? Oops. Oh. Insulation resistance become low. What does that mean? It will flex in one direction and stay there. Yeah, probably. Yeah. It still should work though. I think we leave it like that. Okay, that's about it. This is that project. Now I have another one going on. We can do that next, or talk about it at least. Where's my array here? So that one here. I need to set up a camera so you can see that, because let me check that. Easy stream today, isn't it? Oh, I need a power supply as well. Okay. This is the power supply, 5 volts. Yeah. 5 volts, 2 amps. Oh, power supply should be even enough, since we have OTA. Why is this cable so short? Okay. Ah, the mount. Okay. Okay. Coming up next, maybe you have to sacrifice one for science. Yeah, will certainly. We will test that. The problem is that we won't hear it. Maybe you have to make an empty roter Fruchtzwerg case become a speaker. What? Oh shoot. Camera. I wish I had enough space to invite people to stay here and work a little bit. Oh, this cheese needs a little bit of cooling. I'll remove the cheese, otherwise my lab will stink as hell. Here, it's a little bit cooler. Okay, let me show the camera if it's working. Here we go. Okay, ooh, 64 by 64, and we have, I show you stuff just you will not believe. What's the name? Trinity. Okay, here we go. Code. WebSocket screen share. Connect. Does this work? No. Does it work? Ah. Try to connect. If it not, it doesn't connect. What's the matter? What's the matter, my friend? It seems to be rebooting. Failed. Okay. WebSocket client. Booting. Doesn't work anymore. No, I don't know what's wrong. Oh, wait. I might have an idea. Maybe my Wi-Fi is completely broken here. It's overwhelmed with all the devices. That was restarting. Do you think it's the IP address? Why is it restarting though? There's something wrong. Connection failed, rebooting. I just restarted my Wi-Fi here. Might be
That might explain why fail is failing. SSSHHTTT for Photo Pro Max. Maybe API key stuff? Darmok and Jalad at Tanagra. What about beat frequency effect? Write him back, what's going on? Are we there yet? Okay, time
Hello,
for
Buster.
bed. Good night all. Test.
Oh, who went
Test.
off?
Transmit the same sound at a different delay, so the sounds that matches collide at a different spot in the room.
Oh no.
EYYYYYYYYYYY. Finally.
Okay, bitluni is working, okay.
Yay, it works.
I don't know. It's the router all the way. Maybe it's the router. We need an automation when stream is live and we don't see a fail for 10 minutes. It has automatically to restart the router.
Now you need to set up a monitoring thing for your network like Meet P.
Yeah, we need to do that. You need to vote for that on the next stream. Okay, so what we can do here, we can screen share. Let's put something on our screen. Let's say we share this screen. So the problem currently.
TJEN, the stream will be also gone or not? Why
No.
don't you ever use MQTT? It would be great for most of your use cases.
Okay. Do you see? Okay, MQTT might be great, but I don't know. In this case, it wouldn't matter because MQTT
He
was
only
also
restarted
Wi-Fi.
the Wi-Fi app, not his main router.
Okay, so no. What's happening is I have my PC connected to a switch, a basic switch, and I have this extra router connected to the same switch. So this extra router, Wi-Fi router here in the basement.
No, MQTT is great, not might be great winking face.
Okay, it's great. But in this case, it wouldn't matter because nothing worked with the Wi-Fi here. I needed to restart the Wi-Fi in the lab, and that fixed everything. So what you can see right now is, maybe I should show the compression ratio. What's happening is,
No, just use MQTT H_L.
okay. Where is it? Where is my other?
You needed to restart the lab and make sure the boobies are set up on the router.
Psst. No, not serial monitor. I need a serial plotter. Okay. If it starts working again. Did it break? Did it crash? Let me restart that. Oh, it was probably... Oh, yeah, the sharing was in the background.
I think the Serial Connect caused the MCU to reset.
No. This needs to be in the foreground. This needs to be in the foreground. Okay. We need to reconnect. Okay, here we go. It's sharing again. And then I will show you the outputs. Here. Okay. So
If guests come to stay or family at your house, do you have a different password for them to use on your Wi-Fi, or do you share your breast password with them?
Brett, I don't know what you are talking about. I have no idea what you are talking about. There's no such thing at my place. Okay, so these are this.
It's the heartbeat of the sharing.
Yeah. Okay. So what you see here is my current state, and there are some bugs still. There are some bugs that I need to fix. These are new.
The serial plotter that is.
Oh, it turns into a sexist stream again. Okay, this is the serial plotter. What it plots is the bytes received per frame. So guess what the peaks here are. Guess what these peaks are.
According to that graph, your heart is in trouble, bitluni. Full frames.
Yes, that's like keyframes. It's called keyframes. I send them like every second. I send one keyframe. You can see it blinking probably from time to time. And the keyframes are compressed with PNG currently. So that's...
Still wondering why the AP stops working. Too many loony packets. Winking face.
Yeah, probably. It's the cheapest Wi-Fi router you can get from Amazon. It's like $20. So I don't expect too much stability there. Especially regarding the UDP packets. Okay, so we have, I don't know if you can read that. It's like a full frame. Okay, this is not like
Poor
very
router.
fancy.
Is bitluni abusing you greater than?
Yeah. Let me...
Wi-Fi by Charm High.
Wi-Fi by Charm. Yeah. Let me put something on the other screen. Okay, here. I put something else on the other screen. Okay. So this is like if you run a video and PNG does a great job.
Just use a Raspberry Pi as a router.
Yeah.
You know the rules and so do I. So why is the frame rate so slow, bitluni?
What frame rate is so slow? The frame rate is awesome. Usually a full frame requires what is it? 64 by 64 times 64.
Never gonna give you up.
4 times 3 bytes is 12 kilobytes.
USB Wi-Fi at focal point of parabolic dish gets you far.
Oh yeah, okay. Okay, so 12.288 bytes is the uncompressed frame. Now we have PNG lossless compression every keyframe. These are the peaks here. And we have very action.
What are those blocks in the video stream? Compression error?
Okay, we have like zero blips here. This is when there is no new frame. And I tell you why in a second. Because I implemented a compression. Let me pause it. Okay, here it's paused. Nothing changes anymore. So uncompressed, like PNG compressed frame is about 4 kilobytes right now. 4 kilobytes. That's 1/3 of the uncompressed one. Okay, we have the black bars next to the image. But what I do is between the keyframes, I just calculate the difference. So the difference, like the deviation between the pixels to the next frame, it's always like smaller than like the complete value. And then I compress that with PNG. So these are all PNG, like this, I don't know how many, this is like maybe 200 bytes, 400 bytes. These are also PNG compressed images, but all gray. It's only gray because there's no difference in the image. If I start it again, and many things change there, we still have the peak keyframes here, but we are able to save a little bit on the frames in between. It's not like much in such an active video because there are like people jumping around and stuff like that. And PNG compression is already quite great, but this is something like a basic video compression here. But you can see like what's the difference between the individual frames. There are still some bugs in that. I can see like some pixels here that are strangely, I don't know if this is like an error with the signs or whatever. Compression PNG. Yeah, no, it's like animated PNG. Oh, we also are able to compress that grade with PNG because this display is using only 16-bit values, and we basically filter that out before we compress the image. So I can maybe share a little bit of the code, but I think it's almost getting late. I wanted to fix the errors right now. Let me change. Open folder. Oh, where's the Trinity? Okay, so code-wise, oh yeah, you have that screen here. This calculates basically the delta video callback that captures the frame. And where's the compression happening? Calculate filter pixels. That's what we are doing to filter basically already the bits that we are don't need to compress. So you can see the RGB values. 16-bit is like only 5 bits blue and red and 6 bits in green. So we basically filter out the least significant bits already and compress that one afterwards. So we have like filter pixels first, and then we count the frames and we calculate the delta if it's not like the 0 frame. So we have like 60 frames per second. And when we send 60 frames, we reset the frame counter, and that basically converts to PNG and sends the complete blob. PNG, convert canvas to PNG, that's cool. Cool trick. You can get an uint array, and then you get a to blob. Wait, convert canvas frame. Socket send, and you can basically create a blob with an array of blobs or some kind of data.
Would that work on a TTGOT display?
Yeah, sure. Sure. That works on any display. So video compression, but this is like a very simple video compression. And I think there was like an article recently of a dude that made like a super simple compressor decompressor for images. And what I think is, okay, he did like some minor what he was doing was run length encoding, and he was also encoding the difference between pixels. Like if you have like copy the pixel that was like 15 pixels ago and change it by a little or something like that. He was basically compressing like the 24 bits into like 8 bits or something. This was his compression method. Was really simple. Yeah, it's a quite interesting article. If you go to the GitHub, I don't know if I can find it. If you check out the GitHub, people hopped on that and implemented statistics, what tags are used the least and the most. And basically some of his tags weren't used at all, or like 0.1% of the time. So you could basically assign longer tag bit length for the tags to be optimized in that way. So people are already optimizing that, so there is no final specification for that. But what I thought, if that really works that well, so I also heard someone saying it's only like for regular images, it's only like 50%, it compresses to half the size, so it would be like 6 kilobytes. And instead of the 4 that we have with PNG, but PNG is already quite big. Okay, I used Larry's library to decode. Let me check the code for you. It's and it's already, it would be a hassle for, where's the code? I don't see the code. Show me the code. Where's the code? Oh, here. It was a tiny window. Okay, so I'm using Larry's PNG decoding. That's a library, and it's still not very like it probably won't work on super cheapo Arduinos or whatever. It might, but I'm not sure if you don't need like a lot of memory or anything. He decodes like line by line. So you get a callback and you can write a line and whatever. And using maybe the other compression, I could adjust the compression to use like between frames, the changes between frames. So not only like 2D, how it was there, but also use the delta of compress the delta between the frames. So if you have a screen like we see here, where only like this portion changes and some flickering up there and maybe my mouth or anything, not much is changing there. Maybe I can share another screen. Let me check that out. Okay, let me reload this, connect, and share basically the same screen here. So this will be shareception. And let's check. Okay, so this is really, that's making a difference. Look at this. It's only, I would say 1.2 kilobytes. Yeah, 1.2 for uncompressed, and the delta compression goes down another like 40%. And we have some errors grabbing the frame, so whenever we get a frame that's not really a new frame, there is like this minimal compression. Okay, but I think I won't be able to fix the bugs that are still there. This is something that I wanted to release. So because this is like, we can get like a seriously cool, okay, this is like an error now. I don't know what the matter is with that. Sometimes I think we lose a frame or something. This is like in the bottom. It shows also the frame number. There might be something wrong, like an order or something of the frames. It's increasing itself.
That's not an error, it's the serial graph.
No, what I mean is, here down there, there might be sometimes a frame missing, so the delta isn't correct anymore, and then you see something like that, wrong pixels. So in that case, we either need to communicate, it's broken, or we need to wait for the next keyframe, or we need to like adjust slowly to the error. Deviation is not high enough to trigger a new pixel. Yeah, but I monitor. I think I'm monitoring the. Let me think. Maybe you are right. Because we have some filtering, but I'm monitoring. Where's the delta? Monitoring the last value that we send. It should be the last value that we send, not that we read from the screen. Wait, that's not a screen share. Calculate delta. No, it's always calculating the delta. It's filtering first, then calculating the delta. We are not using the delta error, so you could basically, if you would use a lossy compression on that on the image, you could also accumulate like an error that you could basically try to fix next frame. So if we want to maybe use only 4 bits for the delta between each frame in the compression, then we could have like accumulate an error there. Okay, but this is like going too far. I don't see like this arrow delta pixels. It's storing the pixels. Yeah, delta pixels. So the delta pixels are the pixels from the last frame. And this is basically storing the delta there. 256. This is just an experiment. 255 minus R, G, and B. That shouldn't change anything. Yeah. Ah. Okay. Oh, we got an error. There was an error and now it's gone. Oh, I think there might be also a problem with the asynchronous way JavaScript works. You should be able to catch read rows via callbacks instead of checking for it. Yeah, request animation frame. Here, this is like, usually I use like this video callback here, and that should give us a new frame. But sometimes the new frame doesn't change anything. I don't know. It's like this is what we get. Oh, you know what? If there is like, Christian, you're right. If we have like a new frame and the frame has no difference whatsoever, we don't need to send it. We still need to communicate with like that we skipped one frame. Nobody has ever seen Rick Astley and me in the same place. So you are Rick Astley. Yeah, this is something that I still have to figure out. I think it's late now. We have like worked for 5 hours and we did our projects here. Let me show. Where's my new camera? This is not my camera. Where is my... Here, the printer is still there. Yay! Look at this. And we have a pink LED that's not visible. Let me hide the crap. Oops. Okay, let me hide the crap. Here, printer. We did the printer stuff. What else did we do? We planned out our phased array. And now I showed you the current state on the compression, the video compression. Yeah, it's still alive. It looks like it's still alive. Let me go there. Let me put on some music for you. And let's roll the music here. Where's the music? Here. And I go over there.
Raspberry Bird Cam HVAC Quote L.
I saw it. I saw it. I saw it. I was there on screen. Ah. Let's share a different screen. This one here. Screenception. We could put, okay, we can see the printer here. This is the printer. Okay, everyone. Raspberry Bird game. Not it was CGI. Luniception. Yeah, I tried to be at two places at once. Didn't work properly. Okay, people. Next time we will have a blast. No one-day challenge, but we will have a phased array building stream. Next Wednesday. It's close to Christmas. Oh, yeah, Anna, you missed that. I tried. We need to pitch it next times. So thank you everyone for joining the stream today. It was short, underwhelming, and faily as always. We had the fondue was terrible today. And but still, I enjoyed it. Thanks for all the donations. And I see you maybe on Tuesday at 7 o'clock, if I don't forget it. Next Tuesday on Discord, in the video channel, audio channels, or on next Wednesday here again. Yeah, it will be one stream before Christmas still. Bye bye. Thanks for joining. Mwah.